Hack the planet! Hack the planet! Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs after school today. We're doing HackerFrogs free hacking. We're doing all sorts of different things. So let's talk about what we're going to be doing in today's stream. So today is Friday, so everybody TGIF, thank goodness it's Friday. Oreo Bite, nice to see you here. Sonic, nice to see you here on YouTube. And what are we going to be covering today? So we typically do 4 topics on each one of our live streams. The first topic we're going to be doing is Human Resource Machine. This is a assembly-like language that we're going to be coding in, and we're going to be doing that for the first hour. And in the second hour, we're going to be doing the Temperance CTF labs. This is going to be some Python programming, and we're going to be using Python to solve some CTF puzzles. Gerby, hello, nice to see you here on YouTube as well. And yeah, so that's what we're going to be doing in the second hour. And the third hour, we're going to be going into some reverse engineering. It might be closer to binary hacking today, but we've been working on this Nightmare Reverse Engineering course. And we're going to be delving into it, seeing if we can learn a thing or two. And that's going to be the third topic of today's stream, the third hour. And for the fourth topic, we're going to be doing some Active Directory. So we're going to be doing the Intro to Active Directory module. It's actually not on TryHackMe.com. It's going to be on Hack the Box. So we're going to be going there. We're going to be doing that for the last hour, maybe 2 hours. We'll see how long it goes. And those are going to be our topics for today. So we're going to set up the topics. You can see the current topic and the next topic at the top of the overlay on the screen. And let's go ahead and set that up for 60 minutes. We'll do Human Resource Machine for 60 minutes, and then we'll move on to the next topic. Okay, so as usual, if you have any questions about cybersecurity or anything else that you'd like me to answer, please let us know in the chat, and we will try to address your questions and concerns as soon as possible. So let's see. Let me start up the game. It's over here. We will set up the audio. Okay, so you should be able to hear the game now. Okay, and we select our employee, and we're going to go into full screen here. Full screen. Okay. All right, so let's. I think we were having some trouble with the previous time that we were doing this game, but let's jump into the game and see Actually, before we do this level that we got stuck on, let's try this other level here. It's called alphabetizer. Alphabetizer. That seems like it's going to be pretty tricky as well, but let's give it a go. So level 36. We've done a lot of these levels. Okay, so please be advised that this optional hallway is for advanced employees only. Okay? Buzz buzz. Yes. Indeed. Goodbye. Click. Incoming message. You'll receive 2 words. One is a decoy, a false lead, a red herring. The other is part of an important message. Okay, so, what's going on here? So the inbox contains exactly 2 words. Determine which word comes first if you were to order them alphabetically, and send only that word to the outbox. Oh, okay. So we've got some 0 terminated strings that we're going to be receiving from the inbox here. We need to put the word that comes first in the alphabet in the outbox. So let's go ahead and ask some questions. So tell me more. Yes, facilities management has left some useful numbers over there on the floor for you. They were just here. Okay. Did you see them pass you in the elevator? Okay, so give me an example. So if your inbox is Unity until, your outbox should be Unity. Okay, so how are we going to establish which word should be output first? I guess that's what we need to figure out. So in each one of these programs, we're going to have an initialization. So it's a very good idea to label the different parts of your program. Otherwise, you might get lost. So there's initialization, there's going to be a loop, because all of these programs have a loop, and then there's going to be an end part of the program. And let's see. So the last part is going to be the end. Okay. Alright, so. Hoo boy. How are we going to do this? So we need to record the entire word. We need to record the entire word in, it looks like we've got 1, 2, 3, 4, 5. We've got 5-letter words. Are they always going to be 5-letter words or not? I'm not sure about that. So we need to record each one of these. So the initialization is going to be putting down the words. So inbox, and then I guess we need to set up like a counter. So counter first word, and then the counter for the first word, and then the counter for the second word. So we'll do C1, so counter 1 over here. Or counter first word, and then counter second word beside it. So counter second. Sure is some really neat handwriting you got there, Shaihat. Okay. So counter first, counter second. We're going to initialize these both to 0. So copy from 0, and then put it in the counter first, and then put it in the counter second. So copy to, and thank you very much for following Goofball Guinness. Goofball Guinness, thank you. So copy to counter first, copy to counter second, and then we can grab from the inbox. Copy from 23. I did. Oh, right. Yeah, copy from 23, and 23 is 0. So we'll call this 0. And the other one we'll call 10. Okay, so this is 0, this is 10. I wonder what we need this 10 counter for. I guess after we've put down all of the... so 10 would be over here. I wonder what we need that for. I guess 10 would be for the second. 0 would be for the first word, and 10 would be for the second word. So the implication is that the word we're going to be recording is going to be 10 characters or less. Okay, so copy from 0, copy to first word, and then copy from 10. Copy from 10, and then copy to second word. Okay, and then inbox. We need to, when we do the inbox, we need to check if there's the 0, because if the inbox, whatever we get is inbox to 0, we need to stop. We need to stop the thing. I guess we can. What are we gonna do? So let's see. Jump of 0 to the second part. So this is the first part, the first word. Wait. No, not here. Just a second. Okay, so this is for the first word. First W. Okay, and then there's going to be a part for initializing the second word. Second W. Okay, so inbox, and then we're going to copy to Fatcho. Hello, nice to see you here. Welcome to the stream. Okay, so inbox, copy to the index of first word. Jump of 0. Otherwise, you copy to the index of first word, and then you bump first word, and then you bump first word, and then you do a loop. So the loop is going to go like this. Okay, and let's see if this works. So let's just play it. Okay, initialize first word, initialize second word, inbox, put it here, and then bump up. And then grab the second word, put it down, yeah. So this seems to be going okay. So when we get to the end of the first word, we're going to get an error, but that's okay. Okay, then put it in the fourth slot. Now we get the 0. Not enough stuff in the outbox, that's fine. Okay, so let's stop and let's initialize the second word. So to initialize the second word, we follow the same process. So we inbox and then jump if 0. And we're going to go to the loop. I don't know what what this loop is going to be, but these loops over here, we need to copy to the reference of second word, and then bump up second word. So bump plus second word, and then that's going to be a big loop. So this loop is going to go up here. And let's see if this works up until this point. Okay, so here's the initialization. Put it down, and then we're going to initialize the first word. So we put down the entire first word. Okay, let's speed this up a little bit. So we get to the end of the first word. Then we put down the second word. Okay. Okay, good. Good. This part of the program works. So let's stop and reset, and then let's figure out what we need to do from here. So the loop here is we're going to be comparing. We're going to be comparing the letters in the first word and the second word to see which one comes earlier in the alphabet. I mean, I guess that's going to be a subtraction. Okay, what else do we need to keep track of? We need to keep track of which word we're going to select. So it's the selected word. The selected word. So, okay, so I guess we're just going to call this SELW for selected word. And, oh man, I never thought I would be doing complex assembly language stuff, but here we are. Okay, so after the words are established, we need to do something with them. We need to compare the first word and the second word. So to compare the first word and the second word, I guess we can do another loop. So the loop is going to be copy from reference of first word, subtract reference of second word, and do we need to initialize these back to zero? We need to initialize them back to zero before we do this. Yeah, okay, so we're gonna reinitialize those values. Let's see, we're gonna copy from 0, copy to first word, copy from 10, copy to second word, and then we're going to copy from the reference of the first word. We're going to subtract the second word, subtract the reference of the second word. Now we need to figure out how we're going to determine which one to output. Okay, so let's just see if the program works up until this point. So we initialize the stuff. Yeah. Keep going. We got unity versus unwed. Okay. And then we grab the 0. We reinitialize these things over here. We copy from the first thing. We subtract the second thing. Okay, so if it's 0, if it's negative. So if 0, then we can... Von Borg says, you gotta jump. If negative, you can use after subtract. You've got a jump. You got a jump if negative. You can use after subtract. So yeah, so after the subtract, if it's 0, then we're going to keep on going. And we're going to keep on looping. So I guess the loop is in here. So if 0, then we keep on going. Yeah. If you see that my idea and your idea are very, very different, Let us know in the chat. I'm up for listening to other people's suggestions. That's fine. Okay, so we will do the loop. I mean, this is already a loop. We'll just, I guess we can call this loop through loop letters. Or check letters? Check letters. Okay. Odimo, hello, nice to see you here. How are you doing? Doing okay? We're just doing some games. So if 0, we're just gonna go into... Well, I guess this entire thing could be check letters. Okay, so if it's 0, we're going to bump up both of these things. So bump plus first, and then bump plus second word, and then do the thing all over again. So jump up to here. So we need to figure out what to do if they're not the same. If one is less than the other. So if one is less than the other, that implies that so we need to do something in... Okay. Let's just run the program. So it looks like all of the words are the same length. So we got 4 characters here. Oh no, they're not the same. They're not the same length. Huh. That's interesting. Okay. So let's see what happens here. So we initialize both of these words back to 0, or the beginning of their thing. So this is going to be 0. Okay? So we're just going to keep on doing this, and the third one is going to be different. Okay, so I shouldn't have... Sorry. Let's do this one more time. Okay, so what's going to happen here? So these are the same, these are the same. I is further in the alphabet than D, so this has to be the word that's selected here. Vonborg says, you can not reset the counter to 0 because then you forget how long the word is. I mean, the problem in this case is that we have to compare words that are potentially not the same length. So if we don't reset the counters for first word and second word, then the fifth letter of one word is going to be compared with the fourth letter of another word, and that's not gonna work. So let's see. So if we have the larger number, so we need to do... I would use a second counter. A second counter for the length of the word. I'm not too sure about that. But what do we have here? So I minus D is going to be... It's going to be positive. So what kind of instructions do we have? So when we do this comparison, I versus D, we need to select need to select the word undo in this case, and then send it. So let's stop. What tools do we have? So jump if 0, and jump if negative. The problem here is that it's supposed to. This is going to be a positive outcome. We want to jump if positive, not jump if negative. So do we do both operations? Odimo says, I don't understand this game. It's if you go back to previous levels, then it becomes much more easy to understand. Unfortunately, we're pretty far into the game, so it's gotten kind of complicated. Okay, so Von Borg says the positive outcome is the else part of the if negative. Okay, so the positive outcome. So I mean, the positive outcome means that we need to. So if it's negative, if it's 0, we keep going. If it's 0, we keep going. If it's negative, then we have to go to the end. So this is if negative. This means that first word output so there are two possibilities. The first word is going to be output. The other possibility is that the second word is going to be output. So second output. Okay, so if the first word is going to be, well, I mean, let's just write this part of the code because it's easier than what I have the other stuff. So the first word output means we need to reset. So copy from 0, copy to first word 0, and then copy from reference of first word and output it, and then bump up the first word. But then again, how do we... Oh, you know what? Hold on. We also have to put the zeros. We also have to put the zeros into the words, into the word references. Otherwise, we're not going to have a place to stop. Okay. So let's see. So first word. So if it's 0, then we're going to jump over to here. So if it's 0, we copy it to. Not Chemo says you save the word counter for the final output. You have to save the word counter for the final output. Yeah. I mean the word counter. Yeah, we do need to save the word counter for the final output. So after we finish off with the first word and we get the 0, we need to copy it over to. We need to copy the 0 over to the word string as well. This way you don't have to copy the counters. Okay, so copy the thing to the reference of this first word. Okay, and then the second word, we also need to make sure that this one is going to be 0 terminated as well, in which case we would do this. So if 0, then we copy 2, the reference of second word. Okay, let's see if this works. So we're just gonna go on our merry way here. Okay. Whoops. Sorry, everybody. So we just need to make sure that after the P, the 0 is going to be copied over to the next location. Okay. Yeah, and then the same thing with this other one. Okay, and let's... So now that that works, we can figure out how to do the final output. So the final output, if it's the first one, we reinitialize the count for these words, and then we outbox them one letter at a time. We bump up the counter, and then we... Odimo says, do we need to go through a process to get a specific word? Yeah, we're just trying to figure out how to select the words and to grab them one letter at a time, and then put them into the outbox, because that's what the level wants from us. Okay, so we need to do a check if 0. So copy from the reference of this. If it's 0, then actually, wait. I think we don't need this. Kalel, hello, nice to see you here. I'm new to CyberSec. Want to learn and play CTF from which previous live streams should I start to watch? Previous live streams? I mean, you don't need to necessarily watch the live streams. I would say that if you want to do CTFs, you can use this playlist over here. So the very last link over here in the starter pack, this is going to be some easy CTF exercises. If you find that the exercises are too easy, try doing the exercises without using the write-up. If it's still too easy, then you might want to jump ahead in the playlist. There are about 100 different challenges over there, and I'm sure one of them is going to be some stuff that you haven't learned before. But Kalel, let me know what your background is as far as IT stuff is concerned, because that's going to be a big factor in determining where you should be starting. Okay, so yeah, you know what? I think we don't need the 0. We don't need the 0 terminated string, or at least I don't think we do. If it's 0, then you're done with the output. Yeah, I mean, if it's 0, I guess we can just jump over to the very end. V end. Like this. And I don't even know what happens there. I guess you just try to grab from the inbox again? Or something? Anyways, so if it's the second thing, then we do the same thing. So copy from 10, and then copy to the second word. And then we do copy from first, from reference of second word, and then outbox. And we also check if 0. So jump of 0, and then we go to the very end. Oh, we also need to bump up. So outbox and then bump up the second word. Okay, then we just need to figure out how to check letter by letter. how do we check these letters? So we subtract the first letter of the first letter of the first word from this first letter of the second word. If it's 0, you keep on going. If it's not 0, then you have to select one word or the other. So if positive isn't here, if negative is here. Okay, so if 0, keep on going. If negative, you have to select the first word. Peanut Gamer says, what game is this? This is Human Resource Machine. So Human Resource Machine. It's usually on sale. If you check Steam, it might be like 50% off right now. Gonna have to check it out. What is the specific word we want to get? We want to get the word that comes first in the dictionary. So basically, it's alphabetical order. So if it's negative, that means we have to select the first word. If it's not negative and not 0, Kyle says, I'm working at an IT company and good in web app development. I have previous experience in reverse engineering and made some useful apps for myself. Want to excel in, let's see, bug bounty. Huh. Okay, I'm good in SQL and API. So, okay. Let me give you some recommendations, Kal-El. Let me switch over to the other machine. Okay, I've got some learning resources for people who want to learn about this stuff. Let's see, where GitHub. Should you select the second word if it's negative? Hold on. I'll get to that in just a second. So educational resources. We have one for web app stuff. So web app hacking. Here's what I would recommend. So web app education, you probably don't need to know. You probably already know about most of these ins and outs of web apps. You want to take a look at Portswigger Academy. You want to take a look at Over the Wire Natus. You want to take a look at the web app challenges from Pico CTF. But mostly you want to pay attention to Portswigger Academy. It is the best resource for learning about web app vulnerabilities. And Xavier says, what are you doing? So we're just playing a little game right now for the next 25 minutes. Yeah, I'm doing Portswigger Labs nowadays. Awesome. So you're on the right track. And then after you've got a good grasp of that stuff, then you can go ahead and sign up for the programs over at HackerOne and I don't even remember the other really popular bug bounty platforms right now. So let's see. So if the first word is subtracted by the second word and it's negative, that means the first that should mean the first word is the one that we need to select, because that means the earlier letter is in the first word. But if it's the second word, then it's going to be positive. But unfortunately, there's no jump if positive. So how are we going to simulate this? I guess, you know what we should do? We should do this. So jump if negative to another thing. So this will be the selector. Actually, wait. For each one of these words, we need to... If it's not 0... Okay, let me think about this. If it's 0, we keep going. Okay, so Von Borg says, jump after the if negative to the second word. But what? Okay, so this if negative. So we're gonna imagine that A is here, right? So if A is in 0 and B is in here, right? So this is the first word, this is the second word. Actually, let's just demonstrate. All right. So the first word is done. Then we get the second word. Whoops. Whoa. Stop. Okay. So we got the I, right? So the I comes before T. If we do the subtraction of I and then T, it's going to come out negative. And if it comes out negative, we need to select the first word. Okay, Kimo says, you should, if negative, go to the first word output. If positive, then the other one. But what if they're all the way the same? It could be any one of them. So, I mean, the problem here is that there's no jump if positive. There is no jump if positive. It's not one of the instructions we have. So we're gonna do if 0, keep going. If negative, jump over here. Otherwise jump. Otherwise jump. So if negative, if 0. Oh, yeah, okay. I guess we don't need it. So it'll check here. If none of these are true, there's going to be a jump that goes somewhere else. Okay, that should be the right way. Let's play it out. So if negative something, if 0 something, if not, then it is positive, then we jump somewhere else. Yeah, that's right. I think that's what we're supposed to do. You have to check it first if it's 0, and then if it's negative. Only this way you know if it's positive and not equal. Yeah. It took me a little while to come to this conclusion, but thank you for pointing that out. Okay, so we got the first word. Let's zoom until the second word is done. Okay, we got the second word. Then we reset the counters here. We compare the first thing and the second thing. It's 0, so we keep on going. We compare the second ones. Okay. So this should select the second word. So we select the second word, we output these things. Alright, keep going. Not enough stuff in the outbox. What? What happened? Okay, so we outboxed, then we bumped oh, I forgot to put in the loop. Yeah, okay, I need to put the loops into here. So for the first out and the second out. So outbox, bump, and then jump up, back up to the top here. Here. And then there should be one for this one as well. What if Odimo asks, what if negative? What does if negative mean? So it means that if we do a comparison, or if what we're holding is a negative number, or if what we're holding is 0, for instance, then we're going to jump over to another instruction. So let's see, where's that jump? Jump over here. Okay, let's play it out again. All right. So we're going to compare these letters. Okay, so this one should be Okay. So we select the second number. Then we keep on grabbing those letters and putting them in the outbox. You know, oh man. In this game, while you're writing your program, you feel like the dumbest person who ever existed. But when you actually get the solution, then you feel okay. I wouldn't say you feel like super smart. Okay, so your solution works for those specific inputs, but it fails on other possible inputs. Yes, here I'll give you some inputs that cause your solution to fail so you can see for yourself. What inputs are we talking about? Stop and reset, step back and debug. Okay, so we'll stop and reset, and then they'll give us the ones that don't work. You didn't make the condition if both are the same. Hold on. So, is this one to be... Oh, okay. Hold on. Ah, okay. So this doesn't work if... Okay. I think I understand what they're talking about here. So if we compare 0 with this string, if we compare the letter with the number 0, then we need to select one or the other. Okay, how do we do this? I guess each time we increment, we need to check if one of these is 0. How do we do this? That's also why we had to keep the counter to use it. Keep the counter to use it. I think we can get around this. So when we're checking the letters, after we bump up the letters, we'll do a comparison. We'll do a check. Okay, so bump up first thing, and then we'll do a if 0. So if 0, jump if 0. If the first word is a 0, that means we have to select the other word. So we go to second out. And then we bump up the second one. We check if it's 0. If it's 0, we need to go to first out. Actually, so bump, and then we copy from the reference of first word. Then here we copy from reference of second word. We check to see if those things are 0. If they're 0, then we need to jump. Anyways. Brian's, hello, nice to see you here. We're just playing some human resource machine. Oh boy. Okay, let's keep on going. Okay, Unity and Unity. These are the exact same. I mean, we can output any of these. Yeah, so we're going to get to the end. And then we're going to select one of these words. Okay. Alright, and then we start outputting these one of the words. Your solution works with those specific outputs but fails on other outputs. I'll give you some inputs that cause your solution to fail so you can see for yourself. Okay, let's see what they give us now. Okay, keep on going. Huh. Oh wait, what? Step back. Okay, so we should be only... We should select the opposite word in this case. Hold on. I think I've got myself screwed up a little bit. So, let's see. If it's 0, if this first thing is 0, we need to select the opposite word. So jump of 0, jump to second out. Should it be first out? We print the smallest, maybe. I think if we just... Yeah, jump if negative, no. We need to do the jump if 0. So do the comparison. Jump if 0 to first out. Okay, and the other one should be jump of 0 to second out. Okay, QOU. Hey, I really love your stream and enjoyed being part of your fan community. Would you mind adding me up on Discord? My user... Oh, you know what? You can just join this. You can just join the server. Here's the link. So just join the server and then come and introduce yourself in the introduction channel. Thank you. Okay, let's play the thing. Play it out. Okay, it works. Yay! That took a really long time. That took like 45 minutes. It's not very efficient. It's not very efficient. It's not very optimized, but it works. And we got it done. Okay. Digit Exploder, Prime Factory, Scavenger Jane. We got it done eventually. Duplicate removal. So this one, I got stuck on this the last stream we were here. You're fired. Haha, just kidding. But I do have a note here from your other supervisor. She's out sick today. But she says it's time to eliminate inefficiencies. And that's it. Okay, so send everything in the inbox to the outbox unless you've seen the same value before. Discard any duplicates. So, what do we do here? Alright, so let's just play what we have right now. So we got 0, the count and the array position has been initialized. We initialize all these letters that we've seen before to 1. And then current letter you can't sub with mixed operands. Subbing between... Wait. We subtract the count? Well, I'm not too sure what we're doing here. Okay. So one more time. Send everything from the inbox to the outbox unless you've seen the same value before. Discard any duplicates. So... in this case, we need to figure out how to keep track of the letters we've seen before, and my idea was that if we've seen the letters before, we're going to put them in this array over here. So the array is going to be a list of a maximum of 4 letters, although I guess it could be longer. So when we enter the loop over here, Neems, hello, what is good? We're just doing some assembly language stuff. And then after the assembly language stuff, we're going to be doing some Python stuff. So it's a lot of coding today. Okay, so copy from the count. Or the count? Yeah, so the count is 0. If it's 0, we jump back up and get the next letter. But it's not. So we copy from the current letter. So the current letter is A. And then we subtract the count. but I guess we can't subtract the count. We also need to copy 2 the letters in the array. So the letters in the array are kept track of with the counter over here, or the array position. Yeah, so we need to copy 2 the array position. Okay, so copy 2. Copy from the count letter. Inbox, copy to current letter. Current letter, copy to the count. Copy 2. Copy to current letter. And then we need to check to see if we've seen this letter before. This is where it gets tricky. I'm not actually too sure how we do this. But we've got about 7 minutes to figure this out. If we can't do it in 7 minutes, then we'll have to push it back to next week. Huh. So this part of the program is supposed to keep track if we've seen it for the first time. So copy from the current letter, copy to the array position. But how do we tell if we've seen it for the first time? Yeah, this is where I'm not really sure how we're going to be doing this. We can initialize all this stuff. Let's do this one step at a time. So grab the thing. We're going to put it in the current letter. So current letter. Can we speed this up? So, okay. So we initialize all this stuff. We bump up all this stuff here so that it doesn't equal 0, because we're going to be checking to see if these equal to 0 later. We grab the letter, we put it in the current letter. We copy from the index of the count. So the index of the count is 0 right now. Okay. If it's 0, then we need to get the next letter. So basically this is where we check to see if these things are... Yeah, I'm not sure. So jump if 0, copy from the current letter, subtract the count. You can't sub with mixed operands. Subbing between one letter and one number is invalid. Only nice, respectable pairs of 2 letters or 2 numbers are allowed. Okay. Step back. Okay. Man. We need to... I mean, the first one is going to be... The first one is guaranteed not to be something we've seen before. So we can safely just copy it over to the first object of the array here. So I guess we're going to copy to the array position. Okay, so Von Borg says put the first letter in every position of the array so you can subtract. Then you can put the second letter in the counter +1. You can put the second letter in the counter +1. Yeah, I mean that actually makes sense. We should put a legitimate letter in all the positions in the array. Okay, so I guess we're gonna initialize the array with letters in this case. Okay, okay. So copy from. We got this thing. We're gonna copy to the array. Copy to the array position. Odimo says, I want to help, but I'm still missing something here. It's not a problem. It's an assembly language, but and we have to work within the constraints of the assembly language here. So copy to array position. And then, what are we doing? We're going to do a loop. So we're going to bump up the array position. And then we're going to do the check. So if bump up the array position, then copy from the array position. If it's 0, then we need to stop and do something else. Otherwise, we're just going to jump up and loop over and over again. I don't know if this is going to work. Let's give it a try. Okay, we're gonna initialize all this stuff. Sliver says, hey, I did get all the CCNA certifications, now just practicing with configuring the routers and switches to get a job later on as a network engineer. Are the number of letters important, or is it just important to have no duplicates? So we just need to send unique letters. Okay. Oh, you know what? This is gonna go on forever. Never mind. All right. So let me. Okay. So give me the example. If the inbox is these letters over here, the outbox should be only the 4 unique letters. Slever says, I got the game for free. Oh, Slevers, where did you get the game for free? I hope it wasn't anything suspicious. Anyways, well, we're gonna stop. We're gonna stop here. We did manage to finish a level, which is good. But it looks like this level we're gonna have to continue it next time. Okay, let's go ahead and stop. All right, and we're gonna be doing the next topic of the stream now, and the next topic is going to be Python programming. So let's see. So second topic is here, and third topic is on deck. So Slever says Epic Games gives out games for free every week, and on Christmas they give out games every day. It was free on Epic Games. Oh, you know what? I used to keep track of all the free games on Epic Games. I wonder what's free right now. Anyways, we'll keep on playing some music. Then we're going to go over to our Python programming. Yay! We got stuck last time. So last time we got stuck doing, what was it? This level over here. So level number 29. So if you're interested in taking a look, you're going to need an account over at the hackmyvm.eu website. And before we start, we need to do a little bit of setup. So we need to set up.
Hack the planet! Hack the planet! Shut up and get in the...
Chemo, thank you very much for redeeming Hack the Planet. That's what we try to do over here. to varying degrees of success. So we're doing our walkthrough for, let's see, HackMyVM, HMV Labs, Temperance. So we're going to be doing level number 29, but we're going to be using level number 28 as a reference. So we're just going to modify the script from the last level because we don't want to rewrite any code unless absolutely necessary. Because well, programmers are as efficient with their time and effort as they can be. Okay, so this is going to be level 29.py. I'm going to paste in the script from the last level, and we're going to write this out. Okay, so before we start, and if you want to see what script we're using as a base, this is the link over here. All right, let's start the level. We're going to do our introduction. Okay, everybody, this is a guided walkthrough for level number 29 from the Temperance CTF labs from HackMyVM.eu. So in each one of these levels, we've got a mission. We need to fulfill the mission in order to complete the exercise. So it says in this mission, you will receive 2 coordinates. You must calculate how many kilometers there are between them and return the result with 3 decimal places. So for example, we're going to see latitude 23, longitude 21, and we're going to subtract latitude 25, longitude 16, and we're going to return this number over here that is accurate to 3 decimal places. So we need to figure out how to do this in Python. So before we do that, let's just take a look at what we've got for our code right now. So in our code now, we've got the code from level number 28, and we're just going to remove some parts of the code that we're not going to be using. So we've removed our import for JWT, we're not dealing with that anymore. And what we're going to be doing first is we're going to be importing the socket module. So the socket module is how Python deals with communication over a networking port, or an arbitrary networking port in this case. We're going to need a host and a port number. So the host we're going to be communicating with temperance.hackmyvm.eu. The port number is 9988. And the first thing we're going to be doing is we're going to be creating a socket object with the socket module. So with socket.socket, socket.afnet, socket.sockstream as s.connect, host and port. So we create a socket object called s in this case, and then we connect with the socket object by using the connect function over here, over the host and port, which is this over here, so temperance and 9988. So the next thing we do is we use the socket object to receive data. So we print something out, we define a variable, data, and we do s.receive. So we're going to receive a number of bytes from the server. In this case, it's going to be a kilobyte, 1024. We're going to print out what we receive from the server, and then we need to select the level. We need to send something to the server. In this case, it's going to be bytes. So anything that you receive from the socket, anything that you send to the socket, it has to be bytes. Otherwise, it's not going to work. And in this case, we're going to send the level we want to select, which is level number 29. So the next thing we do is we receive the challenge from the server, basically the data that we need to work with. So we send, or we receive more data from the server, and we save that as data 2. What we're going to do is we're going to comment out everything that comes after this part of the script, just so we can work with what we have right now to make sure it works. So we're just going to write out what we have here for the script, and then in another window, we're just going to run the script. Okay, so we received this, latitude 71, longitude 59, minus latitude 13, longitude 29. So we're going to have to figure out how to do these calculations with latitude and longitude, or these are coordinates. We're just going to do a search on Google. So Python latitude, longitude calculation. module. Okay, so we're going to get a handy dandy. So several Python modules are available for performing calculations, including involving latitude and longitude. Okay, we got GeoPy, we've got Haversign. I wonder if GeoPy is part of the standard library. So we like to use standard libraries because standard libraries means we don't have to install anything on our system, which is not something we like to do. So we can just test to see if GeoPy is a standard library. Okay, there's no GeoPy. So we're going to have to, I think all of these are non-standard libraries. So Haversign and lat.lon.calc. The module focuses on handling latitude and longitude values as objects and performing operations like calculating distances, headings, and intermediate points. I mean, this seems like it fits what we want to do the most. lat.lon.calc. Let's see if this is a standard library. So we'll test import lat.lon.calc. Okay, so this is not a standard library, but you know what? We're gonna install it. So in order to install these non-standard libraries, we usually want to use a virtual environment to do this, because otherwise we could get into a really messy situation. So we're gonna set up our virtual environment for Python in here. So Python mvenv myenv. Then we run virtual env myenv virtual env myenv. Okay, and then we can run source myenv bin activate, and then now we're in our virtual environment. So from here we can start importing and installing different modules, and it's not going to affect the rest of our system. So we're going to do pip install lon, is it lat.lon? lat.lon.calc. Okay, so it looks like it should be installed now. So let's see if we can install the thing. Or let's see if we can import. So Python import lat.lon.calc. Okay, so that worked. So that means the module is installed. So let's figure out how to use the thing. So Python lat.lon.calc distance calculator. Okay, so we've got some, I guess we've got the documentation for the module here. Okay, so how do we use this thing? So import the classes. From lat.lon calc.lat.lon import lat.lon longitude latitude. Create a lat.lon object from coordinates. Okay, create a lat.lon object from formatted string. Perform some calculations. Okay. Print the distance. Okay, this all seems pretty. It should be pretty easy to implement. Okay, this is what we're going to do. So we're going to define the latitude and longitude for two points. And I guess what we need to do first is we need to import the classes here. So we're just going to copy this. We're going to insert it into our code. And then what are we doing here? So create a lat-long object from coordinates. Okay, so latitude, lat-long, latitude, longitude. So I guess this would be, we could call this like this variable we could call like location 1, and it's going to be location 1 minus location 2. All right. So I guess the first thing we need to do is, before we do all this, we need to convert the bytes to a string, because I'm pretty sure that this module doesn't work with bytes. Most modules don't work with bytes. Most modules work with numbers and strings. So what we're going to do here is we're going to convert the bytes to a string, and we're just going to call this coordinate string. So coord, maybe coord string, and we're just going to call this data2. We're going to decode from UTF-8, and we're just going to print it out because we want to print stuff out to make sure that everything is working. This message will be, these are the coordinates in string form. Then just print that out. Coord string. Okay. So we're just going to make sure that this works. Python level 29. Okay, so these are the coordinates in string form, latitude 29, longitude 13. So it says minus latitude 36, longitude 43. So we just need to create these objects here with the coordinates. Okay, so this is going to be the next step. So the next step is, I guess the next step is going to be grabbing and defining these numbers. So what we're going to do is we're just going to turn this string into a list so that we can get the numbers from here. Okay, so the next step is separate the string into a list. So I'm pretty sure we can use the split method to do this. So let's see. It's going to be coord string dot split, and we're just going to split by these spaces here. Okay, we're just going to call this coord list, and we're going to print it out. So this is the string converted to a list. So this is going to be coord list, print that out, and then we're going to see if this works. So if it works, we can continue. Okay, this is a string converted to a list. We've got our numbers over here, and we just need to keep track of where these are. So the latitude is going to be, let's see, so this is element 0. Element 0, we got element 1, element 3, and then I think it's element 4 and element 6. Alan Pena, hello, nice to see you here. Welcome to the stream, and thank you very much for the YouTube subscription. Let's give you a fun video redeem. How about Hack the Planet?
Hack the planet! Hack the planet! Shut up and get it.
Okay, so let's see. So after we've turned the string into a list, we can extract some stuff. So extract the numbers. In this case, we're going to define a number of different variables. So it's going to be latitude 1, we're going to do longitude 1, we're going to do latitude 2, and we're going to do longitude 2. Vonborg says you can use minus 1 and minus 3 for the second coordinates. Oh, that's true. That's true. Yeah, we can go backwards to get the other 2 coordinates. Thank you very much, Vonborg. Yeah. Okay. So latitude 1 is going to be coord list, and we're going to be doing this a lot. So I'm just going to copy this, and I'm going to paste it over and over again. Just like this. Okay, so the coordinate list, so latitude 1 is going to be element 2, element 1. So this is element 1, and the longitude is element 3. So the latitude for latitude and longitude 2 is going to be element minus 3 and minus 1 for the last one. Okay, so I guess we're going to print out something here as well, just so we can, you know, keep track of what we're actually recording. And one thing we need to do is we need to make sure that these are numbers. So these are, everything that's copied over using the split method is going to be a string. So we need to make sure that these are integers. So we're just going to use the integer version of all of these things. I really should have thought of this before. So we're just going to apply the integer function to all these things. Okay, and I guess we can print out a message. These are the raw coordinates. And I guess we're gonna print out all that stuff. Okay, so lat 1, lon 1, lat 2, and lon 2. Okay. Comment all this out, write it out, and then run the script again. Okay, these are the raw coordinates, we got these numbers, and let's go ahead and create those objects. So the tutorial here says that, yeah, we've got 2 variables for locations. I'm just gonna copy this. I'm going to copy this format, we're going to put it in our code. So this is going to be, this step is creating the coordinate objects, or I guess location objects. Okay, so this is not going to be Palmyra, it's going to be location 1. Vonborg says the second line is shorter, lat lon. I mean, we can use this. You can use this, and it should be fine, even if it's not super short. It still works. Okay, so location 1, location 2. And we'll just replace these over here. So latitude is going to be lat 1 and lon 1 and lon 2 and lat 2. Okay, and then we can print out a little message here as well. So these are the 2 location objects. Print off the first one, location 1, and then another New line, location 2. Comment everything out, and then run the script again, see if it works. Jarlac, hello, nice to see you here. Thank you very much for the subscription on YouTube. You're now HackerFrog. Let's give you a fun video redeem. How about some Nyan Cat? Actually, we're dealing with numbers. I have a great redeem for numbers.
Hey! Who are you people? What do you want from me?
You want the numbers, Mason. You want the numbers. That's all we've ever wanted.
All we ever wanted were the numbers. Alright, so write that out. We'll,
Hey! Who are you people? What do you want from me?
You want the numbers, Mason. You want the numbers. That's all we've ever wanted.
Okay, so I think this is working. So let's go ahead and do the calculation now. So according to the perform some calculations. So distance equals something. Print distance. Palmyra dot distance Honolulu. Ah, okay, okay. So we can just copy this directly, and it'll give us the distance in kilometers. So this step is calculating the distance. Okay, distance equals location 1 dot distance location 2.
Hack the planet! Hack the planet! Shut up again!
Thank you very much, Jarlac, for redeeming Hack the Planet. Much appreciated, much appreciated. Okay, so let's, I guess we can print that out. Print f-string. This is the distance between location 1 and location 2. New line, and then print distance. Okay, let's see if this works. This is the distance between location 1 and location 2. Nan. Something went wrong here. Nan means not a number. Hold on. Before we proceed, I guess we're gonna do one more little test. So print type for distance. I mean, this should be a number, but who knows? Class float. Okay. Why weren't we able to print off the? If it's a floating point number, then why are we not able to print this out? I'm a little bit confused. Can we just print it out directly? Let's just try printing it out. Okay, let's... So print distance. Okay, so this is a number. I'm not too sure why we're not able to print it out. So the last thing we need to do is we need to cut this off at 3 decimal places, and then send this back to the server. I guess we could, let's see. I guess we're not going to do this as an f-string. We're going to do it like this. Okay. Okay, so this is the distance between location 1 and location 2. Oh. Okay, let's do that again. This is the distance between location 1 and location 2, and then we've got this big number. I guess we need to chop this off. So how do we round this off? It shouldn't be too hard. So Python round float to 3 digits. Or 3 decimal places. Okay, so how do we do this? To round a float to 3 decimal places in Python, the built-in round function can be utilized. So rounded number equals round number 3. Okay, and I guess we're just going to do that over here. Format the number to 3 decimal places. So the rounded number, I guess we're going to call this the rounded distance, is going to be distance round distance 3. And we can print out a message, print f-string, this is the rounded distance. Rounded distance. Okay. Run the code. This is the distance between location 1 and location 2. It says not a number. This is the round distance, also not a number. I don't like this. Why is this not working? So sometimes it works and sometimes we get not a number. Why? Why? You know what? We'll figure it out if the server doesn't accept our answer. We'll start doing some debugging. Okay, so if this is the correct way to do it, the last thing we need to do before we send back the challenge is we need to convert the string or the integer or whatever it is. Actually, wait. We might have to convert this into a string first, because this is going to be a float. So convert the float into a string, then the string into bytes. So this is, I mean, it's pretty easy. We do it just like this. So distance string equals rounded distance, but the string version of it, and then distance bytes is going to be equal to distance string dot decode from UTF-8. So because, let's see, so, oh, this is going to be encode. So decode to convert bytes to string, but we're going to do the opposite, so we're going to encode from UTF-8. I guess the coordinates cannot be negative, so if we get NaN, we could calculation location 2 minus location 1. it it's always going to be location 1 minus location 2. So I'm assuming that the first set of coordinates is location 1, and the second set of coordinates is location 2. It says here minus, so I'm not sure. Okay, but you know what? Let's just complete this part. Print off. This is going to be encode. This is the distance converted into bytes. Print off, what is it? Distance bytes. Okay. Run the script again. So this is the distance converted into bytes. Okay, and I guess we find out right now whether or not it's actually going to work. So we're just going to send the challenge back. So we're going to send bytes. I guess we need to, we're just going to call this bytes here as well. So send the challenge byte, s.send the bytes, and then receive the flag, hopefully. Okay, so that worked. We received a flag. The flag is HMV where I am lost. Where I am lost. Okay. So before we finish off this exercise, let's talk about what we did in the code. So in the code here, we imported the socket. We imported the latitude longitude calculator, which we installed, and then we connected to the host, or connected to the server. We sent the level we want to access, which is level number 29. We received some information, which we needed to convert into bytes first, and then separate that into a string. So from there, we extracted the numbers. For instance, if we got these numbers, this list over here, we've got some numbers. We extracted those numbers to create our latitude and longitude for the two coordinates, or for the two locations. We then created some location objects using the latitude longitude functions inside of the latlon calculator module. Then we calculated the distance between those two locations, and we printed those. We printed them out. We rounded them off to 3 decimal places. Then we sent it back to the server. But actually, before that, we turned those into bytes, and then we sent it back to the server, and then we got the flag. So we're just going to finish the exercise by submitting this flag over here. Okay, we need to log in again. Oh, geez. Okay. HMB Labs, Temperance, flags. Okay, let's submit that flag. Flag submitted successfully. Okay, great. All right, everybody, that was a guided walkthrough for level number 29 from the Temperance CTF labs on hackmyvm.eu. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the videos, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, we're not leaving. We just have to say these YouTube things when we're getting ready to, turn these into YouTube videos. So we're going to be covering level 30 next, and it says in this mission we're going to use XOR and then send the resulting string. I mean, this is going to be a lot easier than what we did previously. But before we do this, we just need to do we just need to record the code we used for this previous level. So we're just going to grab the code that we created here, the script. We're going to save it to our GitHub to document everything. So remember everybody, in cybersecurity, if you didn't document it, it didn't happen. So please document everything that you do, especially when you're doing exercises, because we'll really want to go back to your exercise notes and take a look at them later, just in case you do an exercise that is similar to what you've done before. Create a new file. This is going to be level 29. Oh, this is a Python file. Okay, so we're just going to save out the script. Then we're going to move on to the next level. Okay, so we're just going to rename level 29 over to level 30. Because we're going to be modifying the script. Okay, and let's start the level. Okay everybody, this is a guided walkthrough for level number 30 from the Temperance CTF labs from HackMyVM.eu. So in each of these levels we need to fulfill the mission, and the mission in here says, in this mission you must use XOR and send the resulting string. The key is going to be HMV, so capital letters HMV, and XOR is a bitwise operation. So I can demonstrate very quickly what this bitwise operation is. Let me go over here. So if we've got a binary number, I don't know, something like that, and we have a number like this, we can perform what is called a bitwise operation. And a bitwise operation is basically going to be comparing each pair of these binary numbers, and it's going to be outputting either a 1 or a 0, depending on what the two numbers are. So if the two numbers are the same, so if they're both zeros or if they're both ones, then we're going to output a 0. But if the numbers are different, there's a 1 and a 0, then we're going to output the number 1, and we're just going to repeat that after we compare each one of these numbers. So 0 and 1 means 1, 1 and 1 means 0 because they're the same, and the same here, the same here, the same here, here, and these two are the same, so that's going to be 0. So what we're going to do is we're going to do an operation that is just like this between whatever we received from the server, and we're going to be using a specific key, and the key is going to be the binary number that we're going to be doing the operation with. So how do we? Well, it'll become easier once we actually get the number from the server. Okay, so we're just going to modify the script from level number 29. We're going to delete this import here because we don't need whatever module we're going to be doing there. And yeah, so everything's going to be the same up until this point. Level number 29 is going to become level number 30. So we're just going to sub out 29 with 30. We're going to receive the challenge as usual. And what we're going to do is we're going to save out this portion of the script just to make sure that everything up until this point works. Okay, so run level 30.py. Oh, I forgot to put the triple quotes here at the end. So we're commenting out the rest of the script here, just so that we want to make sure that everything up above the commented out part works, because we're workshopping the script. Okay, write that out, then run the script. So we receive a bunch of bytes. So these are non-printable ASCII characters, and in this case, because we're dealing with the XOR operation, which works on... Actually, I'm not completely sure if we want to convert this over to a string first. That's not a good idea. So these are bytes. These are non-printable characters. We just want to convert this over to binary first. because we need to do the XOR operation. The XOR operation works on binary numbers. Okay, so let's see. Python convert bytes to binary, or binary string, I suppose. Okay, convert bytes to binary. Convert bytes to bits. Bytes to bits. To convert a bytes object to a binary string, a string composed of zeros and ones, to represent the binary value of each byte, you can iterate through the bytes and format each one individually. Use a generator expression. Is there an easier way to do this? Let's see. So my bytes equal this. Binary representation equals bytes to binary strings. My bytes print binary representation. Okay, so before we go on, let me take a look at the description for the challenge. Okay, so they're going to send a bunch of non-printable stuff. We need to print out a string. So Gunpowder on YouTube says, you can XOR bytes to, I think there's a function for it. Well, I mean, I think the better way to do this is to convert each thing into binary, because the key is going to start off as an ASCII string. So we got this key over here. So it's HMV, and HMV is Gunpowder. Thank you very much for subscribing on YouTube. Let's give you a fun video redeem. How about a Hack the Planet? Welcome in.
Hack the planet! Hack the planet! Shut up and get in.
Okay, so key is HMV. We need to convert the key into a binary number as well. So we just need to figure out. I guess we'll try doing this. Converts a bytes object to a binary string. So let's just grab this code. So we receive the challenge, and then we need to convert the bytes to binary code, or a binary string. We've got we have a function that we have over here, so we're just going to put the function over at the top of the script before we run any code. So let's see, bytes to binary string, bytes data, converts a bytes object to a binary string. So return. So I guess this is going to be 8 bits to the byte for byte in bytes data, and I guess we would just run this on the thing that we get. So we run this on data 2. Let's see if it works. So we do an f string. This is the data converted to a binary string. Oh, we should probably name this as well. Let's see. Bytes to binary string. Let's see. We'll just call this binary string. Maybe we'll call it binary string 1. Okay, and then we'll comment out everything else. We'll see if this actually works out. So this is the data converted to a binary string. We've got all this stuff. I hope this is what they want. Okay, so this is the binary string here. We need to XOR this with the key. We'll define the key up here. Actually, let's do it up here. Key equals string HMV. So how do we do this? How do we do the XOR operation? XOR, Python XOR. Binary string on ASCII string. So we might need to do some more conversion first. To perform a bitwise XOR operation between a binary string representing binary data and an ASCII string in Python, you must convert both of them to a numerical representation, typically integers or byte sequences, then perform the XOR operation. Okay, and understanding the input, byte string refers to a string like 0, 1, 1, 1, 0, 1, 1, 0, representing binary digits. ASCII string, this is a regular Python string containing characters. You will work with the ASCII or Unicode values of these characters. So converting the to integers or bytes. So I mean, byte string to integer, let's see. Actually, we don't need to define the key up here. We'll just define it low, below. We'll do it over here. So define the XOR key value. So key equals the string HMV. Then we need to do something to this. Converting to integers or bytes. So binary string to integer. Okay, and ASCII string to byte sequence. Iterate through the ASCII string, converting each character to its ordinal value using ORD. So this is going to be ASCII bytes. ASCII bytes. So the bytes are a decimal value, right? Hold on. Okay, so the ASCII bytes are going to be the key. And let's try printing these out. These are the ASCII bytes of the key. ASCII bytes. Okay, let's see if this works. So this is I mean this is just a list of numbers. If we, I mean these are just decimal numbers. Performing the XOR operation, XORing integers. If both are converted to integers, use this operator right here. So binary integer, some other integer. XORing character by character, I don't think that's what we want to do. So the binary, we need to transform the binary string into an integer. Oh, wow. Huh. Okay. I mean, So the binary integer will be 22. So I guess we're dealing strictly with decimal integers here. That's funny. And I don't know if this is actually going to work, but you know what? We can keep on going. Convert the bytes to binary string. We'll just then to an integer. So the binary integer is going to be the integer of the binary string 1. The binary integer will be, I don't know what it's going to be, but we'll try printing it out. Print f string. This is the integer value of the binary string. Binary integer. Okay, hopefully this code works. We will see. So the data converted to binary string. This is the integer value of the binary string. So we've got this really big integer. Okay, and these are the ASCII bytes of the key. Alright, so we just need to perform the operation. Brandon Cooper, thank you very much for subscribing on YouTube. You are now HackerFrog. Let's give you a fun redeem. This is NyanCat. Okay, so we've got 7 minutes to finish this up. Let's see if we can actually get it done. Okay, so let's see. Resulting integer is going to be binary integer and with XORed on some other integer. So let's see. XORing character by character for strings. This is a more common scenario for XORing an ASCII string with the binary string. If the intent is character-wise operation, you would typically XOR the ordinal value of each character in the ASCII string with the corresponding byte or integer derived from the binary string. Okay, so in this case, the ASCII text would be hello, and the binary key would be this. Length mismatch. When performing a character-wise XOR, if the binary string and the ASCII string are of different lengths, you must decide how to handle the mismatch. You would either truncate, pad, or repeat the shorter one. Okay, so thank you very much for subscribing, Hamisu Rahman. Hamisu Rahman, thank you very much. Let's give you a fun redeem as well. How about go to Hack. Go to Hack and have a great day.
Mr. Hat, may I please be excused from class?
Well, Kyle.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
Okay, and thank you very much for following Unfazed7 on Twitch. Thank you very much. Okay, we got some ads running on Twitch, so we'll run one on YouTube, and we'll put on the birds. Okay, enjoy the birds. We'll be back in about 60 seconds. Just need to have a little water break. Alright, it's time to put the birds away, get back to the coding. So actually, I'm not too sure if this is how we're supposed to do it. But let me take a look at the. We might come back to this level next week, because I'm not sure if we're going to be able to finish this in the next 4 minutes. So we must XOR and send the resulting string. The key is going to be HMV. So I mean, if we've got this here as the input with this key HMV, then we should get this output over here. Let me see if I can use like a web app to do this, because I just want to see what method of XOR we're doing. Let's see, XOR ASCII XOR calculator. Let's see if we can find a web app that'll do something like this. So XOR calculator online. Okay, so input the first thing, hexadecimal base 16. Alright, in which case it would be this over here. So this is the example. In this case, it's going to be ASCII characters. Oh, what is this? Okay, and then we need to XOR it with more ASCII stuff. This is HMV. Calculate XOR. Oh, we need to output this in ASCII. That's weird. Input was blank and changed to 0. What? Huh. I guess this one doesn't work. Doesn't work with us. You know, the funny thing, we've actually done XOR with Python before, but it was a while ago when we were doing cryptography. I think, let me see if I can find those scripts again. You could try CyberChef for XOR. Gunpowder, that is correct. Let me see if I can do that. So cyberchef.io. Yeah, we got some input, we got some output. Let's see, we can do some XOR operations. Okay, the key is going to be in UTF-8, HMV. Okay, so, I mean, we've got something here. So the output is this, but I don't think this is not what they expect. They want the output to look like this. So it starts with T, ends with RIB, but it doesn't work out that way here. That's okay. We can come back to this next week, and we'll see if we can figure something out. We wrote something like this for what is it called? Crypto Hack, the Crypto Hack course. So the Crypto Hack course, we probably, yeah, we got it over here. Crypto Hack. We got XOR stuff. So this is calculating XOR with some other stuff. XOR starter, favorite byte, knows or don't. Okay, so define our variables for XOR operation. So we got encrypted bytes. I mean, we could just use these bytes over here. Key integer 13. So in this case, we're doing XOR bytes, bytes and integers. XOR result. I mean, we're also using the a custom module. Perform the XOR operation, then decode the ASCII characters. So XOR result equals XOR encrypted bytes on key integer dot decode. So we've got, I mean, the bytes in this case would be the key. So the bytes are the key, and the integer is. Anyways, we'll do this next week. I don't want to get too off track. Anyway, okay, so we're going to be moving on to the next topic, and the next topic is going to be reverse engineering. So topic 3 is here, topic 4 is on deck. Okay, so Nightmare, this is a reverse engineering course, but I think it's going to be a lot closer to binary stuff, because I think that's where we're at in the course. So this is the course we're following right now. It's called the Nightmare Reverse Engineering course. Let's put 60 minutes on the clock. We'll start now, and we'll see how much we learn in the next hour or so. So the Nightmare course is free, and all the resources for the course you can find on GitHub. And we've been working through the course. We learned some assembly. We did some reversing assembly. We were using a couple of different tools, and then we did some reversing on a few different binaries over here in this section. In this section here, we finished that last week, and I think what we're going to do is we're going to start into some stack buffer overflows. So stack buffer overflows, I mean, one thing, if I'm going to give like a criticism of the course thus far, is that I think this is all of the reverse engineering that they teach. Everything else seems to be binary hacking. But you know what? I won't complain. It's a free resource. Let's go ahead and learn some stack buffer overflows then. Okay, so for everybody who's wondering, this is the link that we're going to be referencing to do these exercises. Okay, so this one is the Seesaw 2018 qualifiers buffer overflow. Hold on. Where can we get these? We obviously want to get hands-on with these files. I just need to get the GitHub repository for this. Let's see, GitHub. Yeah, so it should be here under modules. This one. So if you're wondering where to get the files to do your reverse engineering, this is where you want to find them. Okay, so let's see. We'll be downloading this binary over here, and we're going to be doing our binary hacking against it. So we're just going to download the file. BOI. Okay, I think we're done with this window here. We're going to close it. Yeah, we'll come back to this level next week. We'll make a new tab. We'll call it... Gunpowder says, do you have a list or directory of all the sites that you're using to learn from? Do you mean for this activity specifically, or for everything we've done in the past? So if you're asking about everything we've done in the past, you'll probably find it over at the HackerFrogs GitHub. Raul Calzada, it's a crime your channel isn't bigger. I mean, if you work hard, if you work long enough, the growth will happen. But yeah, everything that we do, well, all the challenges that we've done, we record them over here in the walkthrough section. We've done a lot of stuff, though. Please keep at it. Thank you very much, Raul. Okay, so let's continue. So we just downloaded that thing. We'll call this tab buffer overflow stuff. We'll give it a fancy color. How about we make this one yellow? Nice. We'll move into the downloads directory, and we've got BOI. So BOI is this is the binary that we need to hack. And let's see. First of all, we need to make the file executable. So chmod +x BOI, and then we can take a look at the binary. So generally, we want to know what kind of file we're dealing with. In this case, it's a 64-bit ELF binary. So this is the standard binary that Linux uses. And what are we supposed to be doing here? So the first thing we can do is we can just run the binary. And I don't know what kind of question this is. Are you a big boy? Are we a big boy? I guess we're gonna give a bunch of A's. So this is classic stack buffer overflow. You provide like a really big input to a binary, and then you overflow the memory locations. So Persona Management says this channel is great for complete beginners. It's a YouTube miracle. I don't know if it's a miracle or not, but thank you very much for the kind words, Persona Management. So it says command not found. Command not found. That's funny. So we provide a really big input. Are we supposed to run a command? Anyways, let's take a look at the course. So the course is good because it explains how to solve the challenges. Okay, so let's go over here. Okay, so it's a 64-bit executable, right? Are you a big boy? And then we provide, I don't know, some numbers. So we can see that we're dealing with a 64-bit binary with a stack canary and a non-executable stack. Okay, so I mean there are protections in place. So checksec. That's the program they're using to check this stuff. Checksec. No, we don't have that installed. Checksec. Okay, so you can do this same check with the program that's already installed on Kali Linux, and I think it's called Robin. So Robin.-I on BOI. Robin is not installed. Oh no, it's Robin 2. Yeah. So this will give you the same kind of output as the checksec command. So it'll tell you what kind of architecture, the binary type, if it has a stack canary, and other protections in place. So it'll tell you the whether it's a big endian or little endian architecture, the language that was used to compile it, in this case C, and a bunch of other stuff. Okay, when we run the binary, we see that we're prompted for an input, and then it provided to us with the time and the date. The time and the date, that is true. So if we just run the binary, we can give it testing, and then it just gives us the time and the date. I mean, this tells me that, this gets me thinking that the binary is actually running a system command. So let's see, if we run the date command does the exact same thing. So our suspicions are that this binary here uses the date command on our system and runs it. Whether or not this can be abused, well, I mean, I guess that's for us to find out. Okay, so it is provides us with the time and the date. When we look at the main function in Ghidra, we find this. So we can also inspect the binary with a few different programs. They use Ghidra here, and I guess we could use Ghidra as well. So if you're using Kali Linux with it, which is like the most common, which is one of the most common, distributions of Linux to use when you learn cybersecurity, you just run the command Ghidra. Just run Ghidra. Oh, it's not installed. Huh. So I guess we have to install it. All right, let's install Ghidra. Hope it doesn't take up too much memory. So it needs 910 megabytes. It's a pretty big program. So we'll just leave this running in the background for a little bit. It should take a little while to install. In the meantime, we can use another tab, and we can take a look at the we can examine the binary using Radare2, which is our favorite disassembly program, and then just R2-D and then the name of the binary, in which case it's a boy. So if we run AAA to analyze the binary, we can then take a look at the main function. So if we take a look at the main function, we do pdf print disassembly function at main, and these are all the instructions for the binary. In this case, it runs bash. It looks like it's running bash, and then it's running the date binary, according to these notes. And it's also making a comparison with dead beef. Dead beef. This is something you're going to run into over and over again. You're going to find into a hexadecimal value equal to dead beef. So this is actually hexadecimal EF, or DE, and then AD, and then BE, and then EF. But it's one of those fun strings that you can spell out with hexadecimal numbers. So are you a big boy? I guess that's a funny question. But yeah, it's definitely using the bin date system command, and it's also using bin bash. Let's see if we're finished installing Ghidra. So if we use Ghidra, on the other hand, to examine the binary, just run Ghidra. It's going to start up the Ghidra program. I agree. Oh, you know what I forgot? Oh man, Ghidra is not very fun to look at if you haven't done a lot of mucking around. Matthew Welty says, I just joined your Discord. Thank you very much, Matthew Welty. And to anybody else, if you want to join the Discord community, this is the link. You can go there, you can say hello, you can talk about getting into cybersecurity, all that other good stuff. Okay, so after you get into Ghidra, we need to start up a project. So we're just going to go over to File, and we can just new project, non-shared project, sure. Project name, we're just going to call this BOI, named after the binary. Okay, then finish. And after we've done that, we're in the BOI project. We want to import a file. So just click on File, click on Import File, and this one is in the Downloads directory. BOI, where is it? Here it is. Select File to import. Okay, so we're going to press OK. And then afterwards, it gives us all this information about the binary. We can just press OK. And to analyze the binary, we just need to double click on it. So BOI has not been analyzed. You want to analyze it now. Press Y for yes. Okay, and then click on Analyze. Okay, so I wonder if there's a dark mode. That would be nice. Is there dark mode with Ghidra? Because this is kind of this is kind of blinding. Anyways, XR says, I remember the first time I ventured into Ghidra, my brain hurt for 3 days. If you haven't used Ghidra before, it takes a lot of getting used to. It takes a lot of getting used to. All right, so let's so now that Ghidra is open, we're examining the binary. Let's take a look back at what we're dealing with here. So when we look at the Ghidra main function, we see this. Okay. So I mean so Ghidra is going to try to create C-like code or C pseudocode. It's going to guess at what C code was used to create the program, and then it's going to print it out for you. If we go to Ghidra here, let's see. We can go over to functions. Functions main. Just click on that. We're going to see in the decompile window. This is the program that we're dealing with, and it tries to make the best guess as to what. Can I make this bigger? I wish I could make this bigger. Properties. Can we increase the font size? Oh, we can increase the font size. Okay, let's make it 24. Okay, awesome, awesome. This is much easier. Okay. Samuel says, sorry, let's catch up with the chat. Oriabite says, I think you have to install a plugin or something for dark mode, but let me double check. Okay. Let's see. Gunpowder says apparently it's edit theme switch, and then select flat dark or whatever you want. Edit theme switch. Edit. I don't see theme over here. Maybe it's somewhere else. Anyways, I mean, it's nice and big, so we can read this. So we've got a main function in here. We've got a bunch of variables defined, and then we got a puts function. Are you a big boy? And then it reads some user input, and then it makes a comparison. So if we're looking at so if our user input is equal to something, it's going to run bin bash. Otherwise, it's going to run bin date. So my guess is that we're looking at we're actually going to be comparing against hex dead beef. Okay, sorry. Samuel says, what learning material would you strongly recommend for a beginner in reverse engineering? Beginner in reverse engineering, I mean, this course is pretty good. It's also free, so let me get the link. Here you go. All right, let me switch up my music, and then we can continue. Oh, OreoByte, yeah, Pwn College. Pwn College is also a great resource for reverse engineering. So it's pwn.college. And thank you very much for following on Twitch. Hardener, thank you. Okay, let's play some music. How about this stuff? Okay, so let me get you the list of education resources for reverse engineering. So if you want to learn reverse engineering, we've got a list of curated list of links. Here it is. Okay, but what are we doing here? So this is what we see when we open this up in Ghidra. So you can see the program prints a string, "Are you a big boy?" with puts. Then it proceeds to scan in hex 18 bytes worth of data into input. So hex 18, this is 16 plus 8. So 16 plus 8 is 24 bytes. In addition, we can see that the target integer is initialized before the read call, then compared to a value after the read call. Looking at the decompiled code shows us the constants it is assigned and compared to as signed integers. OreoByte says, for the list of materials, do you accept pull requests? Well, not right now, but if you want to add your own stuff to any of the education resources, I need to figure that out. But yeah, accepting, well, being able to submit pull requests, that would probably be a good start. Okay, we can see that the value that is being assigned is dead beef, so this is what I suspected. We can also see that the value is compared to this. What is this mangling that's going on? So now that we can see what our input can reach, let's take a look at the stack layout in Ghidra. To see this, you can just double-click on any of the variables that are declared. Here we can see that according to Ghidra, input is stored at offset minus hex 38. We can see the target is stored at offset minus hex 24, which means that there is a 14 byte difference between the two values. Since we can write 18 bytes, hex 18 bytes, that means we can fill up the entire byte difference and overwrite 4 bytes. Since the integers are 4 bytes, we can overwrite. Here the bug is that it's letting us write hex 18 bytes worth of data to a hex 14 byte space. And the hex 4 bytes of data are overflowing into the target variable, which gives us the ability to change what it is. Taking a look at the memory layout in GDB gives us a better description. We set a breakpoint for directly after the read call to see what the memory looks like. So, I mean, we can do this ourselves. Actually, yeah, we can try doing this with Ghidra. So in Ghidra, I have not worked very much with Ghidra, but I guess now is the time to do so. So let's see. So the decompile window is this. Let's close that out. So this is the list view. You know, I'm actually not very familiar with using Ghidra. I am much more familiar with using Radare 2. So here we are in Radare 2. We could set our breakpoint here. And where do they want us to set the breakpoint? Set the breakpoint for directly after the read call. Okay. So directly after the read call is here. So it's going to be this instruction. We can set the breakpoint with db and then the memory address. Okay, and then we can run the DC command to run the program. So are you a big boy? So we're just going to put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, wait, how many bytes are we able to write? So it says we can write hex 18 bytes. Hex 18, rather. So hex 18 is 16 plus, that's 24 bytes. So let's try writing 24 bytes here. Okay, and then we hit the breakpoint. So when we hit the breakpoint, they're asking us to take a look at the memory. So set this breakpoint for directly after the read call and see what the memory looks like. And I guess what they're asking us to take a look at the registers. So in Radare, you can take a look at the registers. So is it? I think it's DR for display registers. So these are the registers. I think what we want to be looking at is we want to be looking at the variables. So we got a number of different variables. I think they said that the variable that is being saved, and that's going to be the puts over here. This is going to be var variable hex 30. So variable hex 30, where is it located? They tell us over here. So variable hex 30 is at RBP minus hex 30. So we can actually take a look at what's in there by doing px at RBP minus hex 30. And this is where our user input ended up being put. So we can see our numbers here, all 24 bytes that we sent to it over here. Okay, but what do they want us to take away from this? Okay, here we can see that our input is hex 14 bytes away. When we give the input this, we need the hex address to be in little endian, least significant byte first, because that is how the elf file will read in the data. So we need to pack it in the way in order for the binary to be read properly. Okay, so we're using a Python 2 command. Python 2 command. Alright, so for some reason, Python 2 is still very popular when you're doing binary hacking exercises. And let me demonstrate what this looks like. So this is Python 2. If we tried to run this command in Python 3, which is the default on Kali Linux, it's going to tell us that the syntax is incorrect. This is because this is a Python 2 command. If we specify Python 2, then it works. So essentially what we're doing right now is we're just printing out hex 14. Hex 14 is 16 plus 4. So that's 20 zeros. So this is 20. 1, 2, 3, 4. Yeah, okay, I'll believe it, and so it's 20 zeros followed by some hex input. So CA F3 BA EE. So these are bytes, or these are hexadecimal bytes. So apparently this is what we're supposed to feed into the binary in order to get it to run the bash command. So we can just run this command and then pipe it into downloads. Boy, are you a big boy? I mean, it didn't give us this didn't give us the input that we wanted to. Actually, let's try adjusting this just slightly. Yeah. So we see here that if we don't give the correct input, it runs the date command, but if we provide the correct hex input, after giving it the correct offset. In this case, it's hex 14. Then it won't run the date command, and instead runs the bash command. But what can we do with this? Okay, we can see that we've overwritten the integer value with this one over here. We can continue on to the CMP instruction, and we can see that it will pass the check. So, I mean, it passes the check, and it runs bin bash, but okay, so they say with all that we can write a hack for the challenge. So we're using pwn tools in this case, and when we run it, just like that we popped a shell. I mean, the problem is that we can't really see the fruits of the labor in this case because we're running it locally. But what does pwn tools do? So pwn tools is a very commonly used Python module that is used to interact with these kind of hacking challenges. So we make the payload equals this, and then send the payload. So drop to an interactive shell that we can interact with the shell. Drop to an interactive shell so that we can interact with the shell. That's a mouthful. Yeah. So I mean, we can copy the script. I mean, it's fine using a script. The problem is that we have not the problem. The thing is that we need to understand what the script is doing. Otherwise, we're just copying and pasting somebody else's code, which doesn't feel really great. Let's move into the downloads directory. I wonder if pwn tools is installed. So Python import pwn. Okay, so pwn tools is installed on Kali Linux. So we're just going to create the script here in the downloads directory. We're just calling I don't know, we'll call it pwnboy, pwnboy.py. Then we're going to paste in the code from the tutorial there, or from the course materials. So from pwn import everything. Okay. So establish the target process. It is this directory boy. Yeah, that makes sense. That's correct. So make the payload. So there's hex 14 bytes of filler data to fill the gap between the start of your input and the target. And there's going to be 4 bytes of input that we're going to overwrite the target. So the payload is going to be zeros times hex 14, and then we're going to add these bytes over here in P32. So P32 is this little endian or big endian? Let me figure it out. So pwn tools P32. Okay, so a beginner's guide to pwn tools. I'll provide the link to this article. So pwn tools is a widely used library for writing hacks. At first, it might seem intimidating, but over time, you will start to realize the power of it. Hanky Lodwig says, use pwn init to create a skeleton Python and patch the binary elf. Pwn init. Well, I mean, I'm not super familiar with using pwn tools. I've mostly been learning how to do binary hacking manually and not using pwn tools specifically. But if you really get serious about doing a lot of binary hacking, you're going to have to learn how to use pwn tools to make it a lot easier on yourself. Okay, so Python 3, Python 2. I just want to know what P32 is. Okay, so if the binary is 32 bits, we use P32. So does P stand for Packer, or does it mean something else? So P64 or P32, it converts the address to 32 bits and 4 bytes. Okay, and so, oh, payload. P stands for payload, probably. That's my guess. Oreobyte says, I like Pwn tools. Python Pwn tools, right? Yeah. That's what we're talking about. So payload 32 and payload 64, depending on if it's a 64-bit binary or a 32-bit binary. Neem says, what you doing? So we're just doing some binary hacking right now using this course. So the course is, what was it, Nightmare? This one. Oreobyte says, Pwn tools is way more... P equals pack. I mean, I thought P equaled payload, but I guess it could mean either. Yeah, I mean pack is equally fine. Sick of the Mind, hello, welcome to the stream. Haven't seen you in a while. Actually, were you here last stream? I think I saw you here last stream as well. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get in.
Okay, so it looks like this is Little Endian order. But, I mean, you can make this Little Endian order or Big Endian order. It doesn't really matter that much. But I guess it's, okay, when we run it, we pop a shell. I mean, okay. I wonder, so let me take a look. Is this, let's see. We can also pack as Big Endian by using Endian Big in the parameters, but I'm guessing that the order that we're putting it in is going to be Little Endian by default. Okay. Sick of the Mind says I was. No worries, no worries. I think I noticed, yeah, you talked for a little bit. Okay, so we've got our payload over here. We just need to target.send the payload and then target.interactive in order to get an interactive shell with the target. Okay, so let's try running the script. So just Python pwnboy.py. Stop the process. Can only concatenate strings, not... Okay. So I think we need to run this with Python 2. No module named pwn. So do we need to... We need to adjust the script, because this is... what we have right now is compatible with Python 2. Target@send, interactive... Do we need to specify... Do we need to specify bytes? Like this? This is the reason... Oh, you know what? We could do this... I mean... If you do, let's see. If you do B, you have to send bytes with the 0. Okay. I think this should still be okay. Okay, it worked. I mean, there was some... Who am I? Yeah, we're the Shy Hat. But, yeah, we managed to get a shell by interacting with the... with the vulnerable binary. Can exit. Got EOF while reading interactive. Can we? Yeah, we can interrupt this. Okay, so that's one down. Okay, so we wrote a hack for the challenge. Okay, great. Then we ran it. We popped a shell. So what's the next challenge? So let's see. Von Borg says, is the shell from the binary or from the Python program? It should be from the. It should be from the Python program, because the actual shell is defined. Here. So target.interactive. So send the payload and then drop into an interactive shell. So it is the Python script that is running the shell. Okay, and let's try the next exercise. So Tamun 19 pwn 1. So the bash in the binary is doing nothing. No, the bash in the binary is doing the shell. I think we also get a shell if we run it like this. Where are we? So if we just run it like this, we send the payload using Python 2. This also gives us an interactive shell. No, wait. It was supposed to be 14. Hold on. Let's start an sh shell first of all. So we'll start an sh shell. Who am I? The Shy Hat. And it should, if we run this command, it should give us a bash shell. Okay, Gunpowder says, and thank you very much for following, Colo. Colo, here's a fun video redeem. How about some keyboard cat? Okay, so this is an sh shell. So when we run this command here, it should give us a bash shell. Actually, let's do echo shell. Oh, it says ZSH. I mean, this is an sh shell because we can't move around in our we can't move around in the command line. But after we run this, this should be a bash shell now. But I don't know, it's hard to tell. If you set the SUID bit on the executable, then run the exploit from a normal user, you should see your privileges escalate. Gunpowder, that's a good idea. That is a good idea. Let's do that. Exit. Yeah, let's do that. So we got the BOI. Let's make this an SUID binary. So let's see. chmod u plus s, I think. So this is now, oh, you know what? It's owned by the Shy Hat. We need to become the root user first. Become the root user. Authentication failure. Wait, what? Fixit, thank you very much for rating the channel. Everybody, Fixit is another Twitch streamer. Another Twitch streamer who does cybersecurity content. Here's a shout out for Fixit42. Go and follow Fixit42's channel. And welcome raiders. My name's the Shy Hat. We're currently learning about binary hacking over here. So let's run that command with sudo. Okay, so it should be. It's still owned by the Shy Hat. Okay, let's try chown root or sudo chown root on BOI. Okay, let's make sure that went through. So this is a root owned binary. It's in Oh, it's no longer an SUID binary. So let's run that again. Okay, and yeah, let's take a look. So now it's an SUID binary for sure. So if we were able to run the hack on this binary, then we should be running as a root shell. Fixit42 says, "How's it going?" We're just working through our reverse engineering course over here. So it's Guy in a Tuxedo. It's the Nightmare course. We're just working on, well, actually, we're not working on this one yet, but it's the same course. Okay, so let's let's see if, I mean, we ran the thing, but we didn't seem to get our interactive shell. So let's run the script. Let's run that script. Huh. We're still working with our regular user. Nice, you find so many free courses. I mean, that's what I do. I try to help people find free education resources so that they can learn about cybersecurity stuff. But yeah, unfortunately, we weren't able to demonstrate the privilege escalation off of this. I'm gonna do some research a little bit later, but let's move on to the next exercise. Okay, we got about 14 minutes. We'll see if we can do this in 14 minutes. Probably not. Okay, so let's take a look at the binary. So we got a new binary to look at now. It's going to be over here. So Tamu 19 Pwn 1. And I guess they also have the Python script. They've got a flag. I mean, I guess we should make a flag file in our directory as well. Okay, we're gonna download this file. Nope, we're gonna download the file. Von Borg says, "Thank you for the explanation, Gunpowder." Yeah, thank you very much, Gunpowder. Okay, so we've got... What is the file called again? So it's called... Pwn 1. Okay, so it should be... Here it is. We'll make the file executable. And I think we need to create a flag in this directory as well, because I think the goal of the exercise is to read a flag. So I'm just going to echo out something to call it flag.txt. We got the flag. That looks okay. All right. So as usual, we should probably figure out what kind of file this is. So this is a 32-bit ELF binary, and we can run rubin2 to figure out what kind of memory protections it has. So architecture x86, bin type ELF, 32-bit, canary false, little endian, all this good information. Okay, so they stop. Who would cross the bridge of death to answer me these questions 3 ere the what? Ere the other side I see. What is your name? I don't know that. Okay. Let's do this ourselves. So run pwn 1. So we need to input something. What is your name? The Shy Hat. I don't know that. Okay, so obviously we need to do something. We need to provide the correct input to the binary here. So I mean, my first instinct is just to use Redare 2. Fixit42 says, good night everybody. 3 a.m. Wow. Really, really late, Fixit. Let's give you a keyboard cat to send you off. And hope to see you next time. So you can use Redare to take a look at Pwn 1 and take a look at what's happening inside the binary. So after you run it, you analyze the binary with the AAA, and then you take a look at the main function. So PDF print disassembly function at main, and apparently there's some sort of function that lets you print the flag according to the instructions here. Okay, it's a pretty long program compared to the other ones that we've seen. And another thing we can take a look at is we can take a look at strings inside of the binary. Let's get out of here. So just run the strings command on the Pwn binary, Pwn 1. And I suspect we've got, so we've got the question that we're asked by the binary inside of the strings. Right off you go, flag.txt. I mean, it's looking for flag.txt, and I guess this is what happens if you answer correctly. Sir Lancelot of Camelot, I don't know that. What is your quest? What is my secret? Are they looking for these strings? If we run, what is your quest? I mean, I'm to seek the Holy Grail. What is my secret? I mean, they're all in the strings here. What is my secret? Is it this? I mean, I don't think it's this. But we'll give it a shot. Okay, so the last comparison, the last question, we need to figure out what it's probably going to be. A buffer overflow, probably return to win. Yeah, probably. Let's take a look. So we were taking a look at the main function over here, and we want to take a look at all the functions. So inside of Redare 2, we can do the AFL command, which is going to return every function. And I guess the one that we need to pay attention to in this case is going to be the one that prints the flag, or the win function, basically. But yeah, Pebble, welcome to the stream. I need to take a break right now because we got ads running on Twitch. But we'll be back in about 60 seconds. But in the meantime, enjoy these birds. We'll be back in after our water break. Oh, Gunpowder says, I just checked and apparently Bash and modern shells automatically drop privileges if they detect that they're running with the SUID bit. I didn't know that. I mean, I didn't know that either. I mean, I guess you learn something new every day. Let's put the birds away. Let's get back to our binary hack and stuff. So is it modern bash and modern shells? Are we talking about the OS environment? Does it matter if we're using like an older OS or not? Okay, so we want to run the print flag portion of the binary right here. So this is a function that we need to get access to. So let's check. So over here, we've got our 3. Actually, wait. Can we just go directly from here? Can we just, give a bunch of input? Now, like the actual bash executable, if it's a bash executable from an earlier operating system, then maybe it'll still work. Okay, so well, let's just try giving this like a big, really big input. So something like this. It says file name too long. Okay, so I mean, what we need to do is we need to figure out if we're, well, the other possibility is that they actually want us to figure out what the secret is. I mean, we could probably figure out what the secret is with some reverse engineering. So let's see, PDF at main. So this is the print flag function here, but how do we get here? So the comparison, the D word is with this. So it's a pretty direct comparison. Can we feed it just this? So jump not equal. This thing. Pebble says that defeats the purpose of an SUID. Well, I mean, we were trying to experiment with a binary that runs bash. Okay, so this is what we need to feed. This apparently this is what the binary is looking for. And it's a little endian binary. I mean, I mean, we could use a payload kind of similar to what we did in the last exercise. What was it? Something like this. But we don't need to print anything previous to this. We just need to print out this thing. So it's pwn1. And is it what? DE A1 10 C8. So this might not be in the correct order. But what happens if we've got multiple lines that we need to give it? Okay. So if we've got multiple lines that we need to feed it first, how would we pipe it in? So print this, and then print another thing. Okay, so if we know that this is the final string that we need to feed it, could we print something else first? I mean, I'm pretty sure we can. I think what we're looking for is like Sir Lancelot for the first question. Sir Lancelot of Camelot. Okay, okay. So that's the first question, and then we can do the second question answer over here, which is, what was it? The Holy Grail something something? This one. To seek the Holy Grail. Okay, and then what is my secret? So the secret here is going to be the last one. So the last thing is going to be print this. Okay, so that's not the right one. So we switch around the order. So to switch the order, /x C8 /x 10 /x A1 /x DE. That's not correct? Are you sure that's the actual secret and not the address of the secret? Oh, that's also something that could be coming into play. You know what? Let's give ourselves another 15 minutes to work on this exercise before we move on to the next thing. 15 minutes. Okay. Are you sure that's not the actual? That's true. It could not be the actual secret. Okay, so let's take a look one more time. So Radare 2 on this thing, analyze the thing, then take a look at the main function. So the comparison here, var 10h, and var 10h is, you know, the third thing that we send, I'm assuming. It's going to compare it with this right here. So this hexadecimal. So compare dword. This isn't a reference. It should be directly this. Jump not equal to C2. It goes over here. Otherwise, it jumps over to this port. Oh, you know what? Huh. Even if you get it right, I don't think you get the flag. So maybe what you need to do there is you need to send it a bunch of junk data, or overwrite the buffer. Okay, so in this case, let's try sending a times, I don't know, 1000. Segmentation fault. Okay, so I think this is what we need to do. So the secret doesn't matter. Even if we send the secret, it's not going to print the flag for us. So what we need to do is we need to send it the correct offset. Now I'm actually not too sure what the correct offset is. We can probably figure it out. Okay, so we know. Oh man. Let's set. So right after, we need to set a breakpoint. I think we need to set the breakpoint right after we do the comparison. Actually, no, not right before we do the comparison. So the program should crash if we send too many characters to this right after this call. Okay, so let's set the breakpoint there. So db this here, and let's run the program. So what is your name? It is Sir Lancelot of Camelot. Okay, paste that in. What is your quest? To seek the Holy Grail. Here. Here, okay. And then what is my secret? So this is where we need to send like a big input. I'm pretty sure we should probably create a pattern. So let's see, pattern create. What is that command? Oh, you can do it inside of here. Let me look at my notes. So I'm pretty sure if you take a look at the course, they're going to teach you inside of here how to get this done. But I'm trying to challenge myself right now to see if I can finish this without taking a look at the guide. I'm just taking a look at my notes to see how we create that pattern. Okay, so this program right here is going to create a pattern of 100 characters. Is this 100 characters? It looks a bit short. It's okay. Let's copy that. We're going to feed this into the program here. Okay, hit breakpoint. I mean, if we hit the breakpoint, that means it didn't crash. Okay, so we need to make a bigger string. Let's try 500 characters. Okay. So what we're doing is we've got this pattern of characters over here. Fixer42 says here's a guide in a script. You have to change it for it to work, but it's using Pwn tools. Totally fully asleep by now, by the way. Yeah, I mean you seem to be sleeping right now, Fixit42. But thank you very much for helping out and providing the links. SUID buffer overflow generator.py. Generator.py, that's funny. Huh. But let's so we'll try feeding this into the program. Just a second. So we're going to reset the binary and then we're going to run it again. Okay, so what is your name? It is this. What is your quest? It is this. What is my secret? Copy this pattern and then feed it into the binary. Oh, it's a script that you created. Awesome. So hit the breakpoint. I don't know that. Okay, so is this not enough? Wait. This has to be enough to crash the thing, right? Let's try one more time with 1,000 characters. And let's see. Yeah, run it one more time. Sir Lancelot. Seek the Holy Grail. What is my secret? Grab the really long pattern. Put it in there. Hit breakpoint. Continue. Why didn't this work? Let's try this outside. Maybe this one was not an SUID. Half asleep, really going to bed now. Okay, okay. Have a good night, Fixit42. Okay, so we'll run the command we did before. But we're going to just attach this. Okay, so it says segmentation fault. So this should, I mean, this should work. Let's unset the breakpoint. Okay, and then we'll reset the binary, and then we'll run the thing. Okay, so we need to do Sir Lancelot of Camelot. We need to do Seek the Holy Grail. We need to do What is my secret, which is this thing. Okay, so this doesn't crash the program. Soul Hunt, hello, nice to see you here. Gunpowder says it said signal 11 earlier, which is seg fault. Segmentation fault. I mean, is this the pattern we're looking for then? Yeah, signal 11 is seg fault. Okay, so we would look for this pattern with the RAG2 program. So RAG2 that is not valid. And we're supposed to be looking at the EIP because that's what we want to take over. Oh, okay. Wait. We've got the address here. Yeah, okay. This is the address we want. Okay. Sorry about that. Okay. Big endian, little endian, -1. That doesn't make any sense. Am I sending too much? Anyways, let's take a look at the answer. We don't have very much time to finish the exercise. Okay, so the second time it checks for this string, looking at the assembly code, we look for the gets call. We see something interesting that the decompiled code doesn't show us. So it compares the contents of the local variable to this. If it is equal, which would mean it's 0, it calls the print flag function. Looking for the decompiled code for the print flag, we see that it prints the contents of flag.txt. I mean, I don't think it does, but maybe I am completely wrong. So we can use the gets call to overwrite the contents of local 18 to this. We should get the flag. Okay, in order to reach the gets call, we need to send the program the string of Sir Lancelot and then send the Holy Grail. Taking a look at the stack layout in Ghidra. Then we can overflow it and then overwrite this. Putting it all together, we get the following. Oh, interesting. Okay, so So we're overwriting in this case. So we're overwriting with how many bytes? So this looks like 32 plus B. So 32 plus B, B is 11. 32 plus, what is B? So A is 9, B is 10. So 32 plus 10. 42 bytes. So that should be 42 bytes. And then we need to overwrite with this. Oh, you know what? If that's the case, then we should be able to do it like this. So I don't know. So A times 42 plus this. Okay, so I might have the order incorrect here as well. So put C8 here. Okay, what was the... Okay, let's do this one more time. So hex X X X. Okay, so do we have this correct? So print A times 42. I mean, I guess it should be 32 plus 10. Do I have... The only other way this would be is if we need to reverse this. So this would be DE at the end, and then A1, and then 1 0, and then C8. Okay, let's... That's, oh, it's 11? So, okay, so... I mean, 10 is A, isn't it? You know what? Hold on. Okay. Hexadecimal B. 11, okay, yeah, that's right. I'm not counting correctly. So that would be an extra one. So 43. Okay, well, we managed to get it done. Sorry, I had a brain fart and I forgot how to count in hexadecimal. Yeah, but we got it. Yeah, we got the flag. It's just that, yeah, in this case, we're overwriting variables. It's... Wait, is this a... We're overwriting stuff on the heap in this case then, right? Huh. Just need to double check that. Okay, so let's move on to the last part of today's stream. So Well, we're going to be continuing on with the nightmare course. And how many more do we have? I think we've got a couple more for this pwn section here. So buffer overflow stuff. Oh, there's one more. And then what's the next module after this? So variable. I mean, I guess this makes sense. This section is called variables. So we're overriding variables. So the next one is going to be calling the functions and then writing some shell code. Okay, so we'll be coming back to this next week. And yeah, so if you wanted to do this on your own, this is the link over here. Okay, let's go ahead and learn about some Active Directory stuff. So this is the last section of today's stream. And this is Active Directory intro over at Hack the Box. So Hack the Box is it's a really great resource for learning about all sorts of cybersecurity stuff. And this is a pretty extensive module that we're taking a look at today, talking about Active Directory. So Active Directory is how Windows does networking, basically. It's a bunch of computers that are all networked together under a hierarchical system that is called Active Directory. So if you want to take a look at the same stuff we're doing, you can go ahead and look at the link. And let's put a couple hours on the clock. So we'll see how far we can get in about, I don't know, say 90 minutes. After 90 minutes is up, we might be moving on to some other fun challenges. Sozo says, "What's up, Hatman?" Hatman, I've never been called Hatman before, but thank you. We're just starting our little learning topic over here, talking about Active Directory over at Hack the Box Academy. So let's talk a little bit about this. So Active Directory, it's a directory service for Windows network environments. It's basically how Windows does networked computers. Okay, but AD is essentially a sizable read-only database accessible to all users in the domain. To the Hatmobile, Ken PDX, hi, nice to see you here. And you know what? Let's give you a fun Jurassic Park reference.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay. So it's come under increasing attack in the recent years. It's designed to be backwards compatible, and many features are arguably not secure by default and easily misconfigured. So there are a lot of things to know about Active Directory as far as security testing is concerned. And one of the most important things to understanding how to hack a system is how the system works. So if you know how a system works, then you know the CamPDX says a Unix system. Wow, yeah, that's the type of Unix we're talking about. Okay, we've got ads running on Twitch, so we'll run one on YouTube, and we'll take a look at some birds before we come back to our materials today. Okay, so enjoy these birds. We'll be back in about 50 seconds. So if anybody doesn't know what's going on here, this the bird on the left is the parent bird, and the bird on the right is the baby bird. So the parent bird is eating some seeds and then feeding them to the baby bird here. And the baby bird lets the parent bird know what it wants by flapping its wings around. It's a greedy little guy. Okay, let's put the birds away. Let's get back to the hacking. Okay, so a basic AD user, Active Directory user, is it a live cam? It's pre-recorded footage, but it's my pre-recorded footage from my bird feeder. So a basic AD user account with no added privileges can enumerate most objects within Active Directory. So this fact makes it extremely important to properly secure an AD implementation because any user account, regardless of their privilege level, can be used to enumerate the domain and hunt for misconfigurations and flaws thoroughly. So this is something that we take advantage of a lot when we do Active Directory security testing. And, well, one of the things that I really want to get better at is Windows hacking, and most Windows hacking involves interacting with Active Directory. So here we are, we're learning about Active Directory. So Active Directory makes information easy to find and use for administrators and users. AD is highly scalable and supports millions of objects per domain and allows for the creation of additional domains as an organization grows. So we got Active Directory organizations. We have an Active Directory server, application libraries and file shares, and we've got some policy. So enterprise-wide policy and licensing, group policy objects, which manage application portfolios and settings, and then we've got our Active Directory object units, which are stuff like sales and marketing. And thank you very much for following Ral Pictures. Ral Pictures, welcome to the stream. You're now HackerFrog. Let's give you some fun video redeems. How about the frog song? It's the song of my people. Oh, sorry. OUs, I don't know if I said organizational units when I was talking about OUs before, but these OUs stand for organizational units instead of Active Directory. Okay, so it's estimated around 95% of Fortune 500 companies run Active Directory, making AD a key focus for attackers. So one thing I'll tell you about Active Directory these days is that most environments aren't running Active Directory exclusively, which means that the thing that's being used instead of Active Directory is Azure AD, which is the cloud implementation of Active Directory. So as the we're seeing more and more Azure Active Directory instead of regular Active Directory in corporate environments. So as time progresses, you're going to see less Active Directory, which means that that isn't to mean that Active Directory is going to disappear. It's just that we're going to Entra AD. That's correct. That's correct, Day. Laughing Sec says Azure is clutch. I hear that that Azure AD is more secure than regular Active Directory. Camerix, yeah, hybrid environments, hybrid deployments. Most large companies are 70-30. So you'll still see a lot of Active Directory, but over time it's being replaced by more and more Azure Active Directory instead. Okay, so as security professionals, we will encounter AD environments of all sizes throughout our careers. It's essential to understand the structure and function of AD to become better informed as an attacker and defender. Okay, so ransomware operators increasingly target Active Directory. Blah, blah, blah. Okay. History of Active Directory. Well, I mean, it's pretty old. Silas Roger. Hello, nice to see you here. Are you making a reference to Squid Game? Is that what you're doing there? But welcome to the stream. Camerex says 80 migrations to the cloud are a pain in the butt for on-prem teams. Yeah, I mean, the good thing about moving to Azure AD over using regular Active Directory is that I guess you don't need as much computing power to use Azure AD. Laughingsex says offensive tradecraft against Azure, I should say. What was that? Azure is clutch. Offensive tradecraft against Azure is clutch. Well, I mean, I heard that. I heard that Azure is more secure, but I guess I haven't done very much testing against Azure, because you need to pay for those services. Okay, so Active Directory was first introduced in the mid-90s, but did not become part of Windows operating system until the release of Windows Server 2000. So, I mean, it's got a pretty long history. Okay, so we're just going to skip over to the next section. Active Directory research over the years. Okay, so I mean, Active Directory, the tools that have been used for security testing against Active Directory, there are a few really big ones. Let's see, Print Nightmare, Zero Login Attack, Kerber Roasting, Spool Sample, ASREP Roasting Techniques, Bloodhound. Yeah, so Bloodhound was a really big thing. It's actually not very old. It came out like less than 10 years ago, but Bloodhound is one of the most widely used tools for security testing against Active Directory environments. Laughingstick says, Azure has a lot of things that are abstracted away from the administrators, so it's sometimes harder to find misconfigurations, or so it seems. Laughingstick, if you have experience doing security testing against Azure, please let us know, because it's kind of something that, well, it's something that I don't have a lot of experience doing. Okay, so PowerShell Empire, right. So it used to be that a lot of extensive PowerShell scripts were used to attack Active Directory, but then it became unpopular because a lot of the tools became detected by modern Windows Defender environments. Okay, let's see, PowerView Responder tool. So I mean, Responder is still used pretty extensively when you're testing against Active Directory. Laughingstick says, a small bit, most of the clients are fully on-premises, or at least environments that give us the scope to attack our. Oh, okay. So on-prem means that you're probably going to see a lot more Active Azure AD. Okay, so Active Directory, Directory Service such as Active Directory Domain, as opposed to hybrid. Vanilla Active Directory as opposed to hybrid in fully on-prem environments. I guess there are some companies that are very against doing cloud stuff. OreoBite is asking, how hard is their AV solution? I think that's directed at you, Laughingstick. Active Directory flaws and misconfigurations can often be used to obtain a foothold or initial access, move laterally and vertically within a network. Okay, so let's see. A basic AD user account with no added privileges can be used to enumerate the majority of objects contained within AD, including but not limited to domain controllers, domain users, group information, organizational units, domain policy, function domain levels, password policy, group policy objects, domain trusts, access control lists. OreoBite, Pebble asks, who is they, when OreoBite is asking about how hard is their AV solution. I mean, I guess they're talking about most of the clients that Laughingstick is working for. So for this reason, we must understand how Active Directory is set up and the basics of administration before attempting to attack it. It's always easier to break things if we already know how to build them. So Active Directory is a hierarchical tree structure with the forest at the top containing one or more domains. Okay. So we have a forest which might have one or more domains and a bunch of child or subdomains. Built-in organizational units such as domain controllers, users, and computers. So these are the objects inside of Active Directory. Let's see. Gunpowder asks how much traditional AD pen testing translates over to hybrid and cloud AD. So Gunpowder, I've heard from other pen testers who work with Azure AD is that it's actually very different. So Azure AD techniques and regular Active Directory techniques are very, very different. That's what I've heard. Okay, so let's see. We've got a root domain and subdomains. So inlanefreight.local. We've got inlanefreight.local corp. We got dev. So these are subdomains. Okay. As well as the other objects that make up the domain, such as users, groups, and computers. We got our GPOs, our organizational units, all that good stuff. Okay, so we got this graphic below shows two hosts, infreightlane.local and freightlogistics.local. So this one and this one. So KenPDX says, philosophical question, if a domain falls in the forest and there's nobody there to hack it, do you still get the flag? That's a good question. I'm sure all of the offensive security people in the audience are very concerned about that answer. Okay, so parent domain, child domain versus just flat, I suppose. Okay, so we got forests and domains. I mean, this is the entire forest, which is separated into two domains. So there is inlanefreight.local and freightlogistics.local. So the whole forest is this thing, and the different domains are the left side and the right side. Oribyte says dev.whatever could be the name of another machine like NetBIOS or hostname. It's dev, but it's on the domain. It looks like two forests. Okay, so we got infreightlane.local, freightlogistics.local. So there's subdomains. These are subdomains here of... So, I mean, this could be one domain and another domain. And they're part of the same forest. Huh, two forests. Oh, okay. Yeah, no, they say that outright up here. So this is forest A and this is forest B. So this one is inlanefreight.local and this is freightlogistics.local. So more like, oh, they're child parent domains rather than subdomains. So these are two forests side by side. Okay, so answer the question below. What Active Directory structure can contain one or more domains? So I'm assuming we're talking about the forest here. Okay, done. So in this example, there's two standalone domains, each in its own forest with no parent or child. So these are, I mean, they're separate domains and they're also separate forests. Is that it? Two standalone domains, each in its own forests. Okay, so they're separate forests and separate domains. So they're not... Okay. True or false, it can be common to see multiple domains linked together by trust relationships. Common to see multiple domains. Okay, so... no worries. Common to see multiple domains linked by trust relationships. Hard to make charts in the chat. It's, yeah. It's, not the best place. Multiple domains linked by trust relationships. in this example, we can see that the root domain trusts each of its child domains, but the child domains in forest A do not necessarily have trust established with the child domains in forest B. Okay, so the question is, multiple domains linked together by trust relationships. I mean, I guess that is going to be true. Okay. So Active Directory provides authentication and something within a Windows domain environment. Authentication and this word. Access? That's not the correct answer. Authorization. Okay. Okay, that's what they want. It's so much stuff that goes into AD. It's a pretty big topic. It's a pretty big topic, and I'm pretty sure that this this module is supposed to last. It's supposed to go over like 4 hours of content. Let me check. I can check how long the module is supposed to be. I'm pretty sure we're not getting through the entire thing today. Introduction to Active Directory. It's supposed to be 7 hours of content. But you know what? I mean, the good thing about this is that it's free and it's available from Academy at Hack the Box. Active Directory terminology, so object. So an object is any resource present within the Active Directory environment, such as the OUs, printers, users, domain controllers. So I mean, if you think about it in terms of object-oriented programming, everything is an object, basically. So attributes. Each object in Active Directory has a set of attributes. So a computer object contains attributes as hostname and DNS name. So this reminds me even more of object-oriented programming. All attributes in AD have associated LDAP name that can be used when performing LDAP queries, such as display name for full and name for given name and first name. Okay, so yeah, it really does remind me of object-oriented programming. So schemas, Active Directory schemas are essentially the blueprint of any enterprise environment. It defines what type of objects can exist in the AD database. Users in Active Directory belong to the class user, and computer objects to the computer class, and so on. So each object has its own information that is stored in attributes. Okay, so it's reminding me even more of object-oriented programming. So I mean, you'll see like classes with a bunch of different attributes like inside of Python as well. So domain is a logical group of objects such as computers. We can think of each domain as a different city within a state or country. Domains can operate entirely independently or can be connected via trust relationships. Okay, so there's the domain, there's the forest, and there's the tree. I don't hear very much about the tree very often. I do hear about forests and domains. Okay, so a forest is a collection of Active Directory domains, so it's a bigger grouping for the domains. Topmost container and contains all the AD objects introduced below. So it's domains, users, groups, computers, and group policy objects. A forest can contain one or multiple domains, and can be thought of as a state in the US or a country within the EU. So what is a tree then? So a tree is a collection of Active Directory domains that begins at a single root domain. Oh, okay. So like a domain and all of its subdomains, that is a tree. so let's see. A forest is a collection of 80 trees. Each domain in the tree shares a boundary with other domains. Parent-child trust relationship is formed with a domain added under another domain in a tree. Two trees in the same forest cannot share a name or namespace. Okay, so we got infrateLocal and ilFreight.local. So these are two trees. A child domain of the first would be corp.inLaneFreight.local. All domains in a tree share a standard global catalog which contains all information about the objects belonging to the tree. Containers. Container objects hold other objects and have a defined place in the directory subtree hierarchy. Leaf. Leaf? I didn't know that there were leaf objects. Leaf objects do not contain other objects and are found at the end of the subtree hierarchy. So GUID, Global Unique Identifier. Okay, so this is a string. GUID value is unique across the enterprises, similar to MAC addresses. Okay. Security principles. These are anything that the operating system can authenticate. I also didn't even know that leaves were a thing. I mean, I guess you can study Active Directory until the cows come home, and you still wouldn't have all this terminology. But I guess you could study this for a really long time. And it goes to show you that you don't necessarily need to know a system completely to hack it, but I guess it does help. Leaves and trees are hardly ever referenced in my experience. I mean, that explains why we've never heard of them. A degree in forestry could help, says KenPDX. That's true. That's true. Okay, so GUIDs, security principles. So these are anything that the operating system can authenticate. So users, computer accounts, threads and processes run in the context of the user and computer accounts. Okay, yeah. So these are all things that need to be authenticated, things that can log in, basically. We can also have local user accounts and security groups used to control access to resources only on that specific computer. These are not managed by AD, but rather by Security Accounts Administrator, SAM. So these local accounts are not managed by Active Directory. Security identifier. So an SID, security identifier. Unique identifier for the security principal or security group. An SID can only be used once. So even if the security principal is deleted, it can never be used again in that environment to identify another user or group. When the user logs in, the system creates an access token for them, which contains their user's SID. All right, let me put on some new music while we're talking about this. So, I mean, the stuff in here is a little bit dry. Hopefully we don't get too bored working through this stuff. Okay, security identifiers. So there are also well-known SIDs that are used to identify generic users and groups. These are the same across all the operating systems. So for example, the everyone group. It's always better when we get to labs. Let's see, LaughInsect, this stuff makes way more sense once you've used AD more. Yeah, I mean, I don't live in Active Directory. The only time I interact with Active Directory is when I'm hacking it. So if I was a regular user or an administrator in Active Directory, it would make a lot more sense. So distinguish name. So the full path to the object in AD. So the distinguish name CN equals B Jones. So what does the CN stand for? So OU is organizational unit. But what is CN in this case? Something name? Something name. computer. It's not computer name. It's common name. Thank you, Laugh-N-Sack. Common name. Okay, so the user B Jones works in the IT department, and just ZU. ZU? You mean like this? Thank you very much for following on Twitch. You're now HackerFrog. Let's remind ourselves of what we're here to do.
Hack the planet! Hack the planet! Shut up and get it!
Okay, so AD does not allow two objects with the same name under the same parent container. But there can be two objects with the same RDN, relative distinguished name. Okay. So it's a single component of the distinguished name that identifies the object as unique from the other objects. So B Jones is the relative distinguished name of the object. So what do we have here? So we've got distinguished name, which is the full username path, and the relative distinguished name is this part. So I mean, it's kind of like absolute file paths versus relative file paths. So if you work inside of Linux, I mean, I guess this applies to Windows too, but this would be the relative file path for this file, and the absolute file path would be the full thing. So this is, so DN must be unique in the directory, RDN must be unique in the OU, or the organizational unit. Okay, so we got the SAM account name. SAMA? Yeah, SAM account name, which is the user's login name. Here would just be B Jones. It must be a unique value of 20 or fewer characters. User principal name. So this is a attribute used to identify users. So the user principal name is the account name plus the domain. So in this case it would be the name plus the domain in question. This attribute is not mandatory. Okay. So in the early days, if you had multiple DCs in the environment, they would fight over which DC gets to make changes, and sometimes changes would not be made properly. This seems pretty fun. Microsoft then implemented last writer wins, which could introduce its own problems if the last change breaks things. There are 5, so wait. What does FSMO stand for? Oh, flexible single master operations. Flexible single master operations. These give domain controllers the ability to continue authenticating users and grant permissions without interruption. There are 5 roles. So schema master, domain naming master, relative ID master, primary domain controller, emulator, and infrastructure master. This is such an in-depth module. I wonder how much of this is actually going to be on the test. You know, be on the test, quote unquote. I wonder how much you need to really remember to do hacking against Active Directory. Yeah, Pebble, you're right. All of the Academy modules are extremely in-depth, and it's good and it's bad. It's good because you definitely want too much rather than too little. It's the same thing with the Linux module. They've got a really good Linux module on Hack the Box, but it's a lot of reading. It's a lot of reading, and I really wish there was more interactive stuff. It would make going through the module much more fun. Okay, global catalog, GC, domain controller that stores all the objects in the Active Directory forest. GC stores a copy of all the objects. Okay. Read-only domain controllers. So these are read-only domain Active Directory databases. No ID account passwords are cached. No changes are pushed. I mean, I think stuff like this probably becomes a lot more relevant when we're dealing with a really large Active Directory environment. But most of the time when I've been interacting with Active Directory, there have been something like 5 computers maximum, and like really specialized roles like this, they've never really come up. Okay, so SPNs, okay, this is something that that comes up pretty often. So service principal names uniquely identify service instance. So this is something that comes up in Kerberoasting. Yeah, Kerberoasting. Kerberoasting deals with service principal names. They're used by Kerberos authentication to associate an instance with the service or a logon account, allowing client application to request the service to authenticate an account without needing to know the account name. Okay, GPOs, so virtual policy settings. So this is, I mean, GPOs are basically the type of settings that may or may not be misconfigured, which can lead to which can lead to insecure settings for users. So access control lists, access control entities, and this is something that's come up a few times when I've been hacking against Active Directory. DACLs, so discretionary access control lists. So these define which security principles are granted or denied access to an object. So these access control lists basically let the system knows which user has access to which files and directories. There are cackles too. Cackles and DACLs. That's we are coming up on Halloween pretty soon. We're like in about a month or so. But anyways. Okay, so if the DACL has no ACE entries, ACE is access control entries. Identifies a trustee and lists which rights are allowed, denied, or audited to given trustees. It seems like there would be like a whole certificate around knowing all the stuff about Active Directory, and like you could get it, and then you'd be qualified to do system administration on like Active Directory environments. But what are RBACLs? RBACLs? Listen. Listen, everybody. There are too many terms. Okay, ACEs and DACLs are checked in sequence until a match is found that allows the requested rights or until access is denied. Okay. So system access control lists. I've never come across this stuff. It allows for administrators to access log attempts. Log access attempts. Oh. I mean, this is... yeah, log auditing stuff. So this comes up pretty frequently as well. Fully qualified domain names, or FQDNs. Camerex says, iCackles. iCackles are the new cackles. Huh. Okay, so FQDNs are the complete name for a specified computer or host. So the complete name. So the complete name is the name of the computer, and then the name of the domain. So DC01. Yeah, so this is the full name of this particular computer. Tombstone. What? Deleted AD objects are inside of I cackled when I learned that too. Thank you very much, Camerex. If you know, it's much harder to learn this stuff if you're not keeping yourself entertained. So a tombstone is a container object in AD that holds deleted AD objects. I have no idea. When an object is deleted from AD, the object remains for a set period of time, and then is deleted attribute is set to true. Okay. Oh, this is the right. This is the recycle bin. Sorry, had to. No worries, no worries. Cartier, hello. Nice to see you here. Welcome to the stream. So AD recycle bin. Okay, so let's see. You can recover deleted AD objects with the AD recycle bin, and I guess this has to do with the tombstone. System vol. Sysvol folder stores copies of the public files in a domain such as the system policies, GP settings, log on log off scripts, and all that other fun stuff. Sever says, you sound like a robot on your short form contact. You sound like a robot on your short form contact. Short form, I'm not too sure what short form contact means. Let us know. Admin SD holder. Oh man. Used to manage ACLs for members of built-in AD groups in AD marked as privileged. Okay, so man, it just keeps on going, huh? Okay, so this is something that I'm interested in taking a look at. So ntds.dit. Oh, short form content. Oh, okay. You're talking about the YouTube shorts. Yeah, I didn't have a very good microphone when I was recording the YouTube shorts. So that's why I feel I sound very robotic. I've got a better microphone now. Okay, so the ntds.dit file can be considered the heart of Active Directory. Okay, cool. It's stored in the domain controller at C Windows NTDS and is a database that stores AD data such as information about the user and group objects, group membership, and most important to attackers and pen testers. Ingo says, hey, this is a good small overview of AD. When you see AD on Microsoft Learn platforms, then you know huge. If this is the short version of Active Directory documentation, then I don't know if I'm ready. I don't know if I'm ready for the full version. But you know what? I think we need to know the cliff notes, like, you know, important stuff like this. Most important to attackers and penetration testers, the password hashes for all users in the domain is going to be in this file. So once full domain compromise is reached, an attacker can retrieve the file, extract the hashes, and then either use them to perform a pass the hash attack or crack them offline. If the setting store password with reversible encryption is enabled, then this file will also store the clear text passwords for all users created or who changed their password after the policy was set. While rare, some organizations may enable the setting if they use applications or protocols that need to use the user's existing password and not Kerberos for authentication. Okay, MS Browse. Networking protocol that was used in early versions of Windows-based local area networks. Huh. I've never heard of MS Browse. Older versions of Windows could use MBT stat to search for the master browser. Let's move on to the questions. Okay, what is known as the blueprint of an Active Directory environment? So the blueprint is the schema. Obviously, yes, of course. I don't think I've seen that either. Are you talking about MS Browse? Nope, never heard of that. What uniquely secures a service instance? Full name, space separated, not abbreviated. What uniquely identifies a service instance? So, service instance? Are you talking about service principal names? They just made it up. Okay, so what uniquely identifies a service instance? Service instance. Service principal name. I mean, didn't I just use that as the answer? Full name, space separated, not abbreviated. Oh, okay. It's not... Yeah, okay, that works. So I was right. True or false, group policy objects can be applied to user and computer objects. Can be applied to user and computer objects. That sounds true. Okay, what container in AD holds deleted objects? The tombstone object. Okay, and what file contains the hashed passwords of all users in the domain? So the ntds.dit. Nice. Okay, let's move on. So, okay, I'm itching to get my hands on the keyboard. Is there a lab component coming up? Please tell me there is. Please tell me there is. Nope. True or false, computers are considered leaf objects. So leaf objects are like endpoints, right? Sozo says, nice chilling with you, I'm off to do some API set courses. No worries, no worries. Thank you very much for coming by, Sozo. Let's give you a keyboard cat to play you off. You know, I wouldn't mind as much if the pages were actually shorter and they asked more questions. So if they asked more questions and the sections were a little bit shorter, then I would feel a little bit better about moving through this stuff. Gunpowder says, redeem frog. Here are the current redeems. What was it? Yeah, redeem item requirements. Here, this is the list. Laughing6 says, I think they need to do more labs per chunk of info. It's not practical to remember all the vocab without seeing it. Yeah. Yeah, I think what you need to be doing is you need to be logged into some terminal, you know, some virtual environment, and then start answering questions by running commands. That would make it a lot easier to work through. Okay, so Active Directory objects. So what's an object? So domains are objects, computers, OUs, organizational units, groups, users, and printers. So users are users. So users are leaf objects. Okay. Contacts. A contact object is usually used to represent an external user and contains information such as first name, last name. So a user and a contact are not the same thing. So these are also leaf objects. Agreed, they could teach you enumeration commands and show the domain structure at the same time. Yeah, I agree. I think this would be a better, probably an easier way to go through this stuff. Because right now it seems like we're really slogging through a lot of text. Okay, so the printers are a leaf object. So basically, we can think of leaf objects as like endpoints on like endpoints on, I don't know, on like a web application or something. So this is not a security principle, so it only has a GUID. So let's see. So contacts are also not security principles. So security principles in general, I guess, they're users or computers that can log into, that can have a login session. And I guess printers have user accounts. Do they? Okay, so computers joined to the AD network. Computers are leaf objects. because they do not contain other objects. However, they are considered security principles, so computer accounts can log in, and computer accounts also have passwords. This is something I actually didn't know that the computers themselves had like passwords, the computer accounts, but apparently that is the case. Shared folders. Shared folders are not security principles. The folders can't log in, so they're not security principles. Groups are container objects, they're not leaf objects. They can be nested. Oh, we can have groups inside of other groups. Yeah, so this can get kind of messy. Organizational units. Containers that they're containers that have that store similar objects for ease of administration. Okay. So organizational units, I mean, what's the difference between an organizational unit and a group in this case? Laugh and Sec, they're generated automatically and long and complex. Nobody is typically using their computer password unless they're doing something malicious, save for very specific situations. I mean, this isn't the case for Linux, I don't think. I'm pretty sure that Linux computers don't have like a system password. They have a root user and a root password. So that makes, that's the difference between, I mean, is this exclusive to Active Directory, or do regular Windows computers have like a computer account? It might be something that's unique just to Active Directory environments. That's my guess. A group is a security object. Oh, okay. So an organizational unit is not a security object. Organizational unit, okay, so stuff like marketing, HR, finance, help desk. If an account were given the right to reset passwords over the top level OU, the user would have the right to reset passwords for all users for the company. Huh, funny. Okay, we got domains. Domain is the structure of the AD network, so the domain is like, the really big thing that includes all the other things. Domain controllers are the brains of the AD network. Laugh and Sex says the computer account needs to authenticate to the domain just like a user would have to, hence the computer's account password. But the password is for the computer's account and not the computer's itself, if that makes sense. Okay, so the computer account is an Active Directory thing. It's not like not all Windows machines have a computer account unless they're attached to an Active Directory domain. Okay. So sites in AD are a set of, this is new. A set of computers across one or more subnets connected by high-speed links. They're used to make replication across domain controllers run efficiently, okay? Built-in is a container that holds default groups for the AD domain. So there's a bunch of different built-in groups that you'll see commonly in AD environments. I haven't heard of this one before. Foreign security principle. Object created in an AD environment to represent a security principle that belongs to a trusted external forest. Oh, okay. So they're created when an object such as a user group or computer from an external network or an external forest is added to the group in a current domain. Interesting. Okay, let's move on. So computers are computed leaf objects. That's true. Blank are objects that are used to store similar objects for the ease of administration. So these are OUs. It's either OUs or groups, right? Okay. Organizational units. I guess we need to type out the entire thing. Okay. Organizational units. Probably wants the full name. What AD object handles all authentication requests for a domain? That is the domain controller. Okay, done. Alright, so Active Directory functionality. There are 5 flexible single master operation roles. These roles can be defined as follows: the schema master, the domain naming master, the relative ID master, the PDC emulator, and the infrastructure master. Jason IT. Jason IT Solution says, how are you? I'm doing all right. Any new better learning platforms for ethical hacking and cybersecurity? Any new better learning platforms? I mean, Hack the Box Academy is a pretty good one. So there's a bunch of the one thing I will point out about Hack the Box Academy is that you need to know where to look for the free stuff. So if you go to Hack the Box Academy after you logged in, you want to look for Tier 0 modules. Tier 0 modules are essentially free. And there's actually a lot of good stuff here. Portswigger. Yeah, Portswigger is another good one. And Pone College is another really good place to learn cybersecurity stuff. Gunpowder says, if you're a student and have an academic email, you can get Tier 2 modules for cheaper too. I hear there are really good plans if you're a university college student. I don't know very much about it because I have never really had to look into it before. Okay, so where are we here? So we've barely scratched the surface. Actually, no. We've actually made quite a bit of progress. Huh. I'm actually interested in this section over here. So I'm just going to skip this section. We're going to go over to Active Directory protocols, because this is the stuff I'm more interested in. Okay, so we got a bunch of Active Directory specific protocols and services. So there's LDAP, Lightweight Directory Access Protocol, Kerberos, DNS, MSRPC, and RPC. Oh, MSRPC, not RPC. Kerberos, okay. So Kerberos is the way you authenticate inside of Active Directory environment. So default authentication protocol for domain accounts since Windows 2000. It's an open standard and allows for interoperability with other systems using the same standard. As far as I know, only Active Directory uses Kerberos. Let's see. Laughingsex says, I don't know if you used Academy before, but if not, I would recommend scrolling down to the bottom of each page before you start to see if there's a lab. That way the machine can be booted while you read. That's probably a good idea. Okay, I don't see anything that needs to be booted up. Okay. Gunpowder says, the student tier is really good. It gives you access to the whole of the CPTS course. Really? And I hear it's on par with the OSCP, content-wise non-recognition. Yeah, I think Pebble took advantage of the student discount to take the CPTS course. Okay, so let's see. When a user logs into their PC, Kerberos is used to authenticate via mutual authentication, or both the user and the server verify their identity. It's a stateless authentication protocol based on tickets instead of transmitting user passwords over the network. Okay, as part of the Active Directory domain services, domain controllers have a Kerberos key distribution center that issues the tickets. If the key distribution center can decrypt the requests as rec using their password, it will create a ticket granting ticket to transmit to the user. The user then presents its ticket granting ticket to the domain controller to request a ticket granting service ticket. This seems very verbose. I mean, maybe it needs to be very verbose. Maybe it needs to be very verbose. Kerberos authentication effectively decouples users' credentials from their requests to consumable resources. I mean, in principle, this sounds really good. Ensuring that their password isn't transmitted over the network. The Kerberos Key Distribution Center does not record previous transactions. Instead, the ticket granting service relies on a valid ticket granting ticket. It assumes that if the user has a valid TGT, that they have proven their identity. Kerberos authentication process. Okay. Hold on, I need to change up my music. I think we might stop for the day. Stop this for the day after this section, and then we'll do some challenges. Okay, so Kerberos authentication process. This is making my this is making my eyes hurt. Well, maybe we'll come back to this. We'll take a look at some of the other Active Directory specific protocols over here. So DNS. So Active Directory Domain Services, ADDS, uses DNS to allow clients to locate domain controllers and for domain controllers to host directory service to communicate amongst themselves. So, I mean, it makes a lot of sense that Active Directory domain controllers use their own DNS because they use domains like, xyz.local. So most of the time they're not using direct IP addresses, and so we need to resolve the IP addresses to different names. Maintains the databases of services running on the network. Okay. Cameric says, Kerberos authentication is like getting a hotel keycard. You prove who you are once with your password to the hotel central system. Then you get a temporary key, which is a ticket to access specific resources, like your room, without re-entering your password for other services. I mean, it's kind of like, I guess in the hotel analogy, you pay for your hotel room with your password, which would be your credit card or something, and then they give you like a pass key that you can use to access services, right? Okay, so 53, TCP port 53, which is typical for all DNS services that are running on servers. So when a client joins the network, it locates the domain controller by sending a query to the DNS service. The keycard to get into your room. Yeah, that makes a lot of sense. When it falls back to TCP when no longer able to communicate, and DNS messages are larger than X number of bytes. Okay. Well, I mean, we've got... I kind of wish we had a machine that we could log into to use this stuff, to use these commands to see, to do some hands-on stuff. Reverse DNS lookup, finding the IP address of a host. Okay, so next thing is LDAP. So LDAP is a really big thing. It basically lets you look up all sorts of information about the Active Directory environment. I think I saw a machine on the right-hand side. Really? Let me take a look. Oh, I mean, this is just the generic workstation. I don't think we necessarily have a machine to access. Okay, so lightweight directory access protocol for directory lookups. So LDAP is an open source cross-platform protocol. So AD stores user account information and security information such as passwords, sharing this information with other devices on the network. LDAP is the language that applications use to communicate with each other and provide directory services. So LDAP is how systems in the network environment can speak to Active Directory. So LDAP sessions, first you need to connect to the LDAP server. The domain controller in Active Directory actively listens for LDAP requests, such as security authentication requests. Okay, so the relationship between AD and LDAP can be compared to Apache and HTTP. Oh, okay. So one is the protocol, HTTP and LDAP, and the other one is the software, Apache and AD in this case. The same way Apache is a web server that uses the HTTP protocol, Active Directory is a directory server that uses the LDAP protocol. Okay? So LDAP authentication, simple authentication, can also be anonymous. Unauthenticated authentication. Okay. User password authentication. So simple authentication means that user password creates a bind request to authenticate to the LDAP server. So SASL? SASL. Simple authentication and security layer. Framework uses other authentication services such as Kerberos to bind to the LDAP server. Okay. So let's see. So the authentication messages are sent in clear text by default. So anyone can sniff out LDAP messages. Recommended to use TLS encryption? Huh. So wait, if you were to monitor traffic, you might be able to see LDAP authentication messages in clear text. Okay, MSRPC, Remote Procedure Protocol, Subprocess, Interprocess. Wireshark, okay. So we got LSA-RPC, Local System Authority, NetLogon, Windows process used to authenticate users and other services in the domain environment. It's a service that continuously runs in the background. I mean, I've heard of this. NetLogon, yeah. And what is this? DRSU API. Directory Replication Service Remote Protocol. Okay, let's answer the questions. What networking port does Kerberos use? Kerberos is port 88. What protocol is utilized to translate names into IP addresses? The acronym, that's DNS. What protocol does RFC 5411 specify? The acronym, LDAP. Okay, so I think we'll pick up next week on more of this stuff. But in the meantime, I really want to hack something. I really want to hack something right now. So let's go ahead and go over to our favorite website, dockerlabs.es, and we'll download something that we can hack. Let's try a medium box. So we've done a lot of easy boxes, and we usually see a lot of the same stuff on those easy boxes. Let's try doing some medium level ones. How about this next one? We've already done Dance Samba. Let's try this one, Veneno. And let's put about an hour on the clock, and we'll work on this for about an hour. Then maybe we'll close out the stream after about 60 minutes or so. Okay, let's download this thing. But let's take a look at what other sections we have in the course. Using machine accounts, directory, active directory groups, security and active directory. I think what we should do, Active Directory Administration Guided Lab Part 1 and Part 2. This is what we should do next time. Okay. Awesome. All right, so we still have our Ghidra running here. Let's get out of here. Okay, so let's go over to, we'll call this Docker Labs. Gunpowder says, are there usually applications websites on Docker Labs? I mean, it's a lot of web app security stuff on Docker Labs, because we're mostly dealing almost exclusively with Linux Docker containers. So let me demonstrate. So over here we just downloaded this challenge. It's called actually, let's get rid of some of these zip files. Oh, but I don't want to get rid of all the zip files. Let's temporarily rename this thing. Actually, wait, we'll just call it Veneno. Just for now, and then we'll get rid of all of the zip files, because too many of them. Then we'll get rid of the tar files. And then we'll rename this thing. And we'll unzip the thing. Oh, okay. Like what you hack, I mean, yeah. I mean, mostly it's web app stuff. It's web app stuff, it's network stuff. Mostly it is web app stuff. But let's go ahead and... So the Docker containers that we access with Docker Labs, they come with an auto deploy script that we have to run to deploy the container. And this is how we just run the script, and then the vulnerable container will be set up, and then we can start hacking. Okay, so we've got our IP address here. Then we can start doing our Nmap scans. Most of the time when you're scanning against these Docker Labs containers, why does it say bicho.dl? Oh, okay. That's from a previous challenge. Let me just delete the stuff in my local hosts. But I mean, either way, it's usually going to be some combination of port 22 and port 80. And I guess we can start hacking more from here. But yeah, Gunpowder, I mean, I use a few different platforms. I generally shy away from using popular platforms like TryHackMe and HackTheBox, because I like to cover more quote-unquote hipster platforms. So stuff like Volnix, HackMyVM.eu, Echo CTF, stuff like that. What are we looking at? Oh, yeah, so this is common IP address. Oh, this is just a default page. Okay, well, sometimes there's juicy tidbits in the contents of these default pages in the comments. Not in this case. Okay, let's do some web app enumeration. So we got index.html and nothing else. What can we do? Let's try another common tool. So Nikto is a web app vulnerability scanner. It's very good for scanning very old technology, old software, old websites. I like to use it because it's not very complicated to set up. And I guess the last thing we can do is we can do a proper web app directory busting attack with GoBuster. GX000, welcome to the stream. We fixed the redeems, yeah. So users can redeem all sorts of great videos now. Okay, we got a problems.php page. That's always fun. Okay, and let's see, we got uploads. Okay, let's check out problems.php. Is this... what's going on here? Problems.php. So problems.php looks like... it just looks like the landing page. Laughing says, are you familiar with nuclei? I haven't used it much, but one of my students is obsessed. Nuclei? I don't think I've heard of that before. Can you tell me what that is? I mean, if I just type in nuclei, cybersecurity? But GX000, how are you doing? Project discovery. Oh, it's a vulnerability scanner. Okay, we were just talking about vulnerability scanners. Modern high-performance vulnerability scanner that simply leverages simple YAML-based templates. Just had a nap? Awesome, awesome. I'm just wrapping up a day of streaming. We're going to be doing some... we're just going to be winding down with this box. Hopefully we can finish it. We'll see. So, I mean, this just looks like the landing page. This looks exactly like the landing page. What can we do with this? Well, I mean, there are a few different things we can do with this. Okay, so we have an uploads directory here. Hanky Lawwig says, what are you doing now? Maybe it redirected. Would have thought that would show in GoBuster, though. I think it might be, I mean, it might be a copy. It might be, oh, it might be loading in the page. It might be loading in a page somehow. Yeah. So another thing we need to pay attention to is the name of the challenge, because the name of the challenge is in Spanish, and I might not be getting the full context. So it's called Veneno. Let's see if that means something in Spanish. Okay, so Spanish veneno is poison. Are we going to be poisoning something? It means venom poison. Light OS, nice to see you here. I mean, yeah. I guess that points to something like log poisoning. So if we're talking about log poisoning, that means there must be some sort of local file inclusion. So this might be how we get local file inclusion. Smells like LFI. Yeah, probably. Nice to be here. Nice to see you here, LightOS. Okay, so let's. If you have anything, if you have any announcements or anything like that, I'm happy to hear them. How's your summer been? Problems dot. Okay, so we can probably fuzz this with FFUF. So if we're gonna fuzz it with FFUF, I probably want to record this in Burp Suite so that I can just use the requests file to get all the user and the user details. But maybe we don't necessarily need to use Burp Suite. Let me see if I can dig up some notes. Let's see, local file inclusion. Let's see if I can find. Yeah, okay. So I think I see something that looks kind of like this with FFUF, but I should probably do this in another tab. So this is technically a brute force attack, so I'll use my brute forcing tab. Okay, so we're attacking this. It's problems.php. And we need to use a specific word list. We're going to be using the Burp Suite parameters list. Where is it? Locate seclist grep parameter. Okay. So we'll use this word list right here to fuzz this problems endpoint for potential local file inclusion. Okay, that gives a lot of nothing. Oh, yeah. You need to make sure that your stuff doesn't have syntax errors. Okay, cool. So we know what the size of an incorrect result is, so we're just going to filter on that size. Ooh, doesn't look like we found anything. So we just need to make sure that this is the correct endpoint. Copy that. Yeah, okay. So, what could be a bigger list? I mean, we could use a really, really big list. Like, user share word lists. dirbuster. Directory list 2.3 medium. And just really go to town on this thing. Backdoor! Backdoor! Okay, sure. Alright. Maybe there's a Spanish word list. I mean, that would be the next thing, but I think we found it. We found the we found the thing we're supposed to do. Okay, so backdoor equals // set your password. Okay, so we got Carlos. So we have a regular user named Carlos. You know you got issues when your landing page is problems.php. I mean, that's not the landing page, but we did a little bit of directory busting to find that. Okay, and then we can... I mean, this is done. And just make sure to add Carlos to the users.txt file. And, well, I mean, this is called poison, right? So we need to figure out if we can access... We need to figure out if we can access the log files. This is an Apache server. Let's curl this thing just to make sure. And head that. Okay, yeah, this is an Apache server. We need to figure out. Well, before we start enumerating for a log poisoning attack, let's try seeing if Carlos has an SSH password or an SSH private key. So not in this case. Okay, so Henke says Henke Lawwick says PHP chain generator to send a PHP command. I don't know if that's the intended path on this one. I might investigate it a little bit later. We have done that before, I think. Home Carlos. Home Carlos. Okay, so where are the log files? Apache server log file location. Okay, var log apache2 access.log. I'm hoping it's not too difficult. Nope, not here. Where'd I look that up? Here. Okay, so let's see. So varlog apache2 access.log and error.log. Okay, ooh, we can see the error logs. Okay. Okay, so if we can see the error logs, then we need to... Wait, what? That's funny. There's all sorts of interesting info in these error logs. Okay, so we need to... Hanky Lawway says, there's an LFI file on seclist to brute force all of the etc. Files. Yeah, I don't... Thank you for letting me know. I don't think that's what we need to do for this box. I think this is going to be a pretty straightforward log poisoning attack. So error.log, let's see. What is being recorded here? We need to figure out what we can... Undefined key array backdoor in... So what is it recording from? That's recorded when you access the ID RSA. Oh, yeah, okay. Okay, yeah. Wait, can we... I see it in the last line. Yeah, I mean, I see it too. Can we put our PHP directly in here? That'd be really interesting if we could. So let's see. So RevShells has a really small PHP web shell. This. So if we could somehow inject this, then we'd be able to run system commands through it. Okay, so this doesn't exist, and then this might get recorded. Be careful to escape the quotes. It can break the access. Okay, let's... Oh. Uh-oh. Oh, no, it worked. Alright, so this thing should be at the bottom then, right? Oh no. Yeah, this didn't get interpreted as code. Otherwise we'd be able to do this. Be careful to escape the quote or the tick. It can break the access. Did I just brick? Did I just... Well, okay. I'm pretty sure that this page... We can't see this page anymore, or can we? Oh, we can see the page. It's just that when I put the URL parameter in there, it doesn't come back. You must use like. You must use like. I'm not too sure. Not completely sure what that refers to. So I mean, what other place could we? Okay, so there's the error. There's error. There's access, and there's one more, right? Okay, well, I mean, I can give it a try. Are you talking about putting it between, like, in between the quotes? Or using it directly like this? The tag PHP. Oh, okay. It doesn't look like... So anytime we use the thing with the URL parameter, it seems to break. It will return back to us. So we need to figure out how to introduce this. So there was a third file we could use for log poisoning. What 3 files use for log poisoning attacks? So it's the access, there's the error, and there's one more, right? So there's access, error, well, we can take a look at a so web server logs, application logs. I kind of want to see if we can use the access logs. So access logs var log apache2 access.log. There's also error.log. Are there any other places it could be? Bunch of logs files in the word list. That's it's a good list. Okay, let's see if we can do some fuzzing then. Seclist master fuzzing LFI JHADX. Where can I find the configuration? Oh, so you know where the access log will write to. That's a very good tactic. Do I not have the JHADX list? No, I mean, it's here. I guess that file path is different. I put fuzz in the wrong place. Oh, you're right, you're right, you're right. So this one is, what was it, backdoor? No such file and directory. I guess... Hold on, I need to replace this thing. Wow, this is really messy. So size, well, I mean, we also want to get rid of the size 0. Hold on. Yeah, there's a bunch of size 0s here as well. Okay, so we've got error.log. So error.log does come back. And it's really big. Could use Panoptic. I've never heard of this tool before. Panoptic. A tool to path traversal. Okay. Oh, you know what? I've heard of this company before. Huh. Websec.ca, huh? Who wrote this? Interesting. Okay, I should check this out. Wow, I've heard of this GitHub user as well. That's great. Okay, so what is this? This is a open source pen testing tool. Automates the search and retrieval of content. Common log and config files through path traversal vulnerabilities. Okay. Yeah. So this is a Python tool. Cool. Okay, clone the repository and make the script executable. And yeah, all right, let's do that. Okay, then let's do this in the research tab. Git clone this thing. I don't know if you need to do chmod on Python scripts, but okay, so it's Python panoptic. So URL list update. So URL, it would be, let me get the path. So this is the path over here. I mean, I'm not completely sure if this is what the program wants. Okay, so there seems to be something wrong with the connection settings. Pre-run with the switch-v. Connection settings, so let's take a look. URL. Do I need to switch invalid SSL to something? Because sometimes running stuff with HTTP is a little bit tricky with some of these tools. Okay, so common patterns, basic LFI testing, filter scans. Ignore SSL cert validation errors. I mean, that's not... let's see. -- invalid SSL. Or do we need to set that to something? Okay, so it's set to true. It's probably checking the path ... So do I need to... Let me take a look at the documentation. Path-based LFI testing. Prefix ... path-based. So let's try path-based. So we'll just point it to this thing. Do we do it like this? I don't think you need path-based for this. So we're just trying to look for parameter-based LFI testing. Okay. Okay. A parameter file. All right. So this is where we already know the parameter name. Add v, you get more output. We got the data, param file. Okay, so wait, what does the parameter file look like? parameter. Oh, so we put a file in there. So add all of your dot dot slashes to the prefix or use multiplier. Okay. Param is the parameter name to test. Oh, okay. Well, I mean, we already have the parameter name. We just need to figure out which. Use backdoor if it's the only one. Okay, so we don't need this parameter here. Okay, so let's see. No usable get post parameters found. I mean, we need to figure out which. Just add, let's see, add backdoor equals X. Ignore proxy. What are you trying to create? Well, I mean, what I want to do is I want to figure out what files I can access using using path reversal. I think the invalid SSL is not used. I mean, let's see. So dash ignore proxy. So how do we use this with the word list for files that we want to try? Parameter with empty value found. Okay, so the parameter, we need to put something in there. Default proxy value. The invalid SSL might be, try putting in apache2.conf. Well, we can get rid of the invalid SSL. I mean, I think it's a pretty good. Invalid escape sequence. It's okay. I really wanted to figure out, like, you know, FFUF is already at this. I just wanted to figure out if we could get access to the log files. So log files, and Sonic asks, how do I install GoBuster? So Sonic, hello, nice to see you on YouTube. Generally, you do something like apt-get install, or like, you know, sudo apt-get install GoBuster. If you, I'm pretty sure it's installed by default if you're using Kali Linux. So if you're using Kali Linux, just type in which GoBuster. If it's installed, it'll give you a file path like this. Is the URL still accessible? I think it is. Let me check. So if you just run like a curl command, this should... Oh. Gotta... This does work out. Let me check the previous command. So the previous command we're doing, I don't have any syntax error stuff in here. There's another file, like I said, on secless LFI. Secless LFI. I mean, LightOS, let me ask for a little bit of advice. So we can access the error log file. I'm just wondering where we're going to inject our log poisoning attack. So our log poisoning payload. Let's see, undefined array key. It's recording the client here. So this is our IP address. Hold on. Let me play some different music. Would access log.log be easier? I mean, I haven't been able to locate it. Somebody said apache.conf. That might be where we look to figure out where the access log is. Okay, so let's see if we can... Is it in the... Let's see. No. Which... Let's see, where is it located? Apache 2.conf file location. So the primary location is etc apache 2 apache2.conf. Okay? So okay, cool. I mean, I see something. One thing you can do in Panoptic is list all files and grep for Apache. Okay, let's see if we can do it in a very automated way. So I'll just remove this and list all files. Okay, so did it work? Oh, okay. This is the list, right? This is the list that Panoptic uses. Okay, cool. Gruntplay, hello, nice to see you here. Welcome to the stream. We're just doing some, we're trying to do some log poisoning. So, I mean, we've got the apache.conf here. We just need to figure out where the access logs are going to be kept. I don't think we're going to get it here. That's the full list. I could grep for Apache to find those paths or to copy the output and use it with FFUF. Edwin, log poisoning. Okay. Let me take a look at the article. Edwin asks, "Did you complete the AD intro?" We didn't complete the AD intro. It's a pretty long course. But okay. So we can look for the logs. Access.log. Grep for it. Sure. Let me do that. So let's see. Grep access. So we'd assume that would be var log Apache or something like that, or Apache 2. Let me give it a try. Okay, so it's not here, but maybe it's in the Apache 2 directory. Not there either. var www logs, maybe. Yeah, we could feed this into something we can use for FFUF. Let's do this. Okay, copy this. We'll put this into another list for FFUF. So nano access.txt. Okay, we got ads running on Twitch, so we'll run one on YouTube. We'll be back in about 60 seconds. Just need to run my ads. But you know what? Everybody, watch these birds. These are my favorite birds. They're baby stellar jays. We'll be back in 60 seconds. It's time for birds. We'll be back after 60 seconds. Just need to have a little water break.
Bud. Wise. Bud. Bud. Wise. Bud. Wise. Bud.
I forgot to mute while I was drinking my water. I hope you didn't hear me gulping down the water. That would be embarrassing.
Bud. Wise. Bud. Bud. Wise. Bud. Wise. Bud.
Okay, let's put the birds away. We heard everything. That's unfortunate. Okay, let's put the birds away. Where's my... Is it here? Okay. All right. So let's switch out this word list for the access.txt list. Etc security access.conf? Really? That's interesting. Oreo sounding tastier now. Yup. Hold on. Let's access this file. Okay, so login access control table. I mean, there's nothing I can use here. I think so. I mean, we can't access any of the access logs. So I think what we should focus on is trying to get command code execution on the error log. So the error log is here. What CTF is this? This is Docker Labs, and Docker Labs is a CTF platform based around vulnerable Docker containers that you can download, or you download them, you deploy them. It's created by a famous YouTube cybersecurity content creator who does content in Spanish called El Pingüino de Mario, and it's actually a pretty good platform. Here's the link. So you just select a challenge, you download it, and you deploy the Docker container. So it could be something to do with the upload directory. Upload a file to the upload directory, then find the directory where it's stored in order to execute PHP. Upload a file to the upload directory, then find the directory where it's stored to execute PHP. I think there's a log poisoning article from the Hacker Recipes that which Grunt has supplied over here. Log files may be stored in different locations depending on var log auth, or here Apache error.log. Hold on. Okay, error.log. This one is similar to access.log, but instead of putting simple requests in the log file, it will put errors in the error.log. Error.log records any errors encountered in processing requests. So let's see. So we want to put in PHP pass-through get command, or something like this. Well, I mean, we can just do this, right? If it actually works out like this, and then go over to anything over here. Just replace the entire thing with this, and it'll get recorded. Okay, not found. That's fine. It should be recorded by the error log, right? And if so, then we just need to use the command URL parameter here. If it actually goes through. But I don't think it goes through. Yeah, it doesn't look like it's going through. Sad. If we just access this normally, it does load up. Let's see. Here. Okay, let's PHP pass-through. Let's search for that. Script pass-through not found. Okay, so I mean, pass-through doesn't exist. We might have to use another method. So not found. What other one-liners could we try? There's some variations. Okay. Let me see if I can find some other web shell one-liners. So PHP web shell one-liner. I see the access log write. Really? Access log write on the error.log. Wait, where? What do you, what am, if that's true, what am I supposed to be looking for? Lamp? I mean... No, this is just fuzzing. This is fuzzing right here. No worries, no worries. So I just need to figure out which... I mean, we could also try PHP systems. There's a bunch of different payloads we could try that use some different PHP functions. Maybe just try to execute an arbitrary PHP, like PHP info, to check if the injection even works. PHP info? Maybe. I mean, I'd much rather get a working web shell. Actually, let's try problems. Problems. PHP. What's the challenge now? Challenge name? Want to give it a try locally. This is a Venemo. So just go to Docker Labs.
Is this a hacking?
Thank you very much, Defus. This is indeed a hacking. Let's see. This is a medium level challenge. It's called Veneno. So just go to, after you've gone to the medium level challenges, it should be the second one on the list. PHP pass-through request frog, of course. You have to stay on brand. Let's see if this gets recorded. Does this go through? Doesn't look like it does. Okay, there was another one. This is PHP systems. So this should result in an error as well. Are you testing your shell or something else? I'm trying to see if I can inject into the error log. So the error log is really big. But I can't get the PHP code execution off. Error dialog basically tells you what's wrong with your method. Have you tried filter chains? I haven't tried. Oh, filter chains, right? Okay, I mean I've done the filter chains thing once, but it's been a hot minute since I tried that. Let me see if I can find it in my notes. Yeah. I mean, I didn't want to try that right away, but let's see. Oh, I see it. Yeah, so there's a script that's used to create filter chains over here. All right, let's give it a try. If you're dealing with the logs, you would put your web shell in something like the user agent. The user agent isn't recorded by the error file over here. So what is recorded here? I mean, if there was something that I could definitely, if there was some parameter I could definitely inject into, you'd have to use the and to exec the log file PHP code, since there was two different PHP files. If you're doing it into the access log, I mean, we haven't been able to locate the access log. It'd probably be easier if we could, but the only thing I've got access to is the error log here. But you know what? We'll try the filter chains. So the filter chain generator is here. Let's go ahead and get that. Copy the raw file. We'll just call this like filter chain dot something something. Is SSH open? You could do LFI through the SSH error log. Oh, SSH is open. Huh. Where is the SSH error log usually? Let me... Okay, man. There's too many directions to move in. SSH error log location. It tells you you're not allowed to include files from var log, but only user share something something. Okay, so location of SSH error logs depends on the operating system. So it might be in var log auth.log. I mean, we can give this a go. It tells you you're not allowed to include files from var log, but only from user share something. Sushant, hello, nice to see you here. Welcome to the stream. Okay, so let's try... Let's try this. Okay, well... Brother, can you make a TCP attack? What do you mean by TCP attack? So, is it... What are some other locations that it could be in? Let's see. TCP DDoS attacks. I mean, I don't usually do DDoS attacks. DDoS attacks are not very... They're not very educational. I've never found I've never had a reason to learn about DDoS attacks. At least check the, let's see, etc. OS release if you're trying to hunt down the file. Okay, so we got etc. OS-release. So this is Ubuntu. Yup. I posted a link to what I was talking about, but it's getting lost in chat. Hold on. So RCE via misconfigured our SSH log poisoning. Okay, let me take a look at the file. Let's take a look at this article. So var log auth dot something something. I'm pretty sure we already tried looking here. Yeah, not var log. I mean, it's possible it could be here instead. Actually, wait. We haven't tried. Maybe it doesn't exist because we haven't tried logging in with the incorrect SSH. Let's try it. Carlos at. Okay, I need to delete the known hosts for this. Okay, let's try again. Yeah, let's see if we can create the log by doing an incorrect attempt over here. Okay, and then that should have created something. No, still can't see it. Okay, no logs. Let's try the filter chains attack. I mean, the filter chains attack isn't log poisoning. The thing is that this box should be log poisoning if, I mean, the name of the box is like poison or venom or something. So I'm not completely sure. Just for fun, we'll try this other one. Frackery, hello, nice to see you here. Okay, so what we were doing some PHP filter chains. So let me copy this. We'll try the filter chain. Luckily, I recorded how to do the thing. Okay, so let's try this. Oh man. Okay, then we can use the payload with the curl command to establish a web shell in RCE. I mean, hopefully. Okay, and let's see if this works. Filter chain has been out for a while now, so I don't know if it's patched. We'll find out. Whoops. This is a really big command. This is a really big command. Okay, so let's paste in the thing. So this is I have a hard time. Juicel Lamau. Hello, nice to see you here. Thank you very much for coming by. We're just trying to figure out how to do our hacking thing. Jeez. I don't know if... Let me try editing my command somewhere else before I paste it into the terminal. Because I've got the command ready for another machine. Okay, so just need to make sure. What are you using for the filter? So the filter is just a very basic PHP, very basic PHP web shell. Oh my gosh. Hold on. Thank you very much for subscribing on YouTube, CM Brooks. Much appreciated. You are now HackerFrog. 172.17.02 172.17.02, and this is going to be problems.php, and the URL parameter is backdoor. Why is this? Why does it look like it has been copied twice? This is really weird. You can just use your browser to paste the URL if it'll make it easier for you. Maybe. It is pretty hefty. Okay, let's... Man. So if this is it right here... One 172.17.02 problems backdoor. Oh man, Aether 1988. Hi bro, your sound is echoing big time. Is it with me only? I think you might have more than one web browser open. That's going to cause the echo to happen. So everybody else, if you're hearing the echo, let me know. Okay, so this works. I'd used my my filter chains. It works. And so oh man. I guess all we need to do But Aether 1988, hello, welcome to the stream. Let's give you a fun video redeem. How about some Hack the Planet? Because we're pretty close to getting initial access on this thing.
Hack the planet! Hack the planet!
Okay, so we use the filter chains attack again through LFI, and yeah, we got it working. So I mean, I guess all we need to do is just get access to this thing. Okay, so what we're going to do now is we're going to set up a reverse shell to catch our catch the incoming reverse shell connection. The dream is dead. We will never hack the planet. The Corpos won. Did the Corpos win? Okay, so let's do a reverse shell tab. Okay, and let's see. We're going to do rl wrap netcat. Good stuff. And I mean, my favorite thing to do is to just do the MSF vnom. Because I sure don't like figuring out which reverse shell command is going to work out for me. Aether 1988 says, which CTF are you solving? So we're doing Veneno from Docker Labs. So Docker Labs, this is a medium level container. It's called Veneno. Okay, so we've got our reverse shell binary file, and then I guess we'll host it here. Let's call this localhost services. Okay, and we'll host the file on here with the Python module. Okay, we got ads running on Twitch, so we run them on YouTube. And it is peanut time. All right, so this guy's having fun. Peanut time. We'll be back in 50 seconds. Okay, so Diva says it works 90% of the time on PHP LFI, so it's the first thing I try nowadays when there's LFI. It's something I should really look into more. Okay. Let's see if we can get this going. So what are we doing now? Let's run which wget. There is wget. Okay, so if there is wget, then we can upload our file. So it's going to be wget http our IP address and then reverse.elf followed by, actually, we need to figure out if we actually uploaded the file. So the file was uploaded. Okay, and 404. What do you mean 404? Temp reverse.elf. Oh, we're in downloads. Oh, never mind. Let's move into the temp directory. Okay, let's do that again. Okay, so yeah, now we actually downloaded the file. Great. We just need to make the file executable. And then we need to run the file to get reverse shell access. Okay, so did we get reverse shell access? Nope. What happened there? Okay, so we did upload. Where did? Huh. Did it? Did we not upload the reverse.elf file? Oh, it could be that we don't have write permissions to this directory. Okay. I mean, if that's the case, it looks like everything's owned by root in here. Yeah, so we're the www data user. We're going to have to save that file somewhere else. So wget our IP address, our IP address. So let's see, reverse.elf. We need to output it somewhere else. So it's -o reverse.elf. Did that work? Okay, so it did get downloaded to the temp directory. So we just need to make it executable. Chmod 777. Okay, and then run the thing. Nothing happened. Nothing happened. Is this the correct? This is the correct IP address. This is the correct port. Nightman, hello, nice to see you here. Welcome to the stream. The reverse shell listener is listening on the correct port. I mean, we can run the file. It is executable. Why can't we run it? And if we can run it, why isn't it giving us a reverse shell? Maybe bin bash? Maybe? Yeah? Or just bash C? Nope. This is curious. How about which bash? Are the outgoing ports open? Usually. Which bash? So, oh, it's user bin bash. Okay. If it's user bin bash / user bin bash c temp reverse.elf. Nope. Okay, let's just try some bash reverse shells now, geez. Actually, you know what? Let's take a look inside of Carlos's directory. So, home Carlos. Thank you very much for subscribing on YouTube. CM Books and Celio or Celio Arias. Let me know. Thanks. Okay, so home Carlos, LSLA, that didn't work. Wait. Carlos? Oh, we can't read it. So only Carlos can read it. Okay. We can't read Carlos's home directory. Let's go ahead and get some sort of reverse shell. Try and port 53. Port 53. Yeah, it could be the port 443 isn't an outgoing port. We could try 53. And I mean that means we need to remake our reverse shell binary. Let me check my IP address. So my IP address is this for sure. It bears checking, because every once in a while it could change. Okay. You can try 80 too if that doesn't work, since you could download files over the HTTP server. Yeah, I mean it could be restricted ports. It could be. Okay, so what are we doing? wget http -o temp reverse 53 http my IP address reverse 53. Okay. And then we'll check the temp directory to make sure that it went through. Yeah, okay. So it went through, which means we can chmod it 777 and then run the darn thing. Nope, didn't go through. Gunpowder says you could try 80 as well if it doesn't work, since you could download files over the HTTP server. Yeah, okay, I mean, I guess we could try... Wait. I'm gonna have to wait to do this. Port 80? Might be worth checking IP tables first. So IP tables is, did I put the dot at the start of the run command? No, I mean it's in the temp directory, and I'm not working inside the temp directory. How's getting a shell? Well, still trying. Usually, I mean, I usually don't have this much of a problem getting this thing done. Okay, let's try it one more time. Okay, so it's wget output temp. It's because I'm streaming, it has to be, right? Yeah. That makes a lot of sense. Okay, so let's see if it got copied over to temp. Reverse 80, yeah, we got it here. Let's make it executable. Okay, and then run the darn thing. But before we run the darn thing, we need to start up our listener on port 80. Nope, still not getting a shell. Let me just double check that the thing is executable. Yep, looks like it's executable. I've got all these reverse shell files. Just sitting in the background video editing. No worries, no worries. Adwitia, hello, nice to see you here. We're just doing some hacking, trying to get some sweet reverse shell access. I don't know if it's happening right now. So let's just try like a bunch of random rev shells. We got our listener on port 80. We can do the good old sh shell here. Just plug and play over and over again. Doesn't look like that worked. So the other thing we need to know is which technologies are on the box. Maybe it's blocking all outbound traffic. What about a bind shell? What about a bind shell? I mean, I do not very often use bind shells, but we could try, sure. Python bind, netcat bind, Perl bind. So I'm pretty sure netcat is on this box. We can check. There's no netcat? Huh, there's no netcat. Is a bind shell like a BDS something? No, not exactly. Not exactly. Okay, so PHP, well, I mean, there is PHP. Alright, so okay, so there is PHP, so we could try this PHP shell. But the only thing about the PHP shell is that we need to change the port. So in this case, I guess I'll make the port 443. And let's see if it works. I mean, there's a lot of special characters in this payload. I don't know if the web server is going to interpret this okay. Okay, paste all that stuff in. Wow. I mean, it looks like it's running. So if it's running, that means we can just netcat directly to the thing. So netcat on port 443. Let's see, Robin Lee says, fix your IP address. Which IP address? What do you mean by fix? Oh man, I used a bind shell. It's been a long time. Bind shell. Okay, everybody, let's call Scary Hacker Voice Man, because Scary Hacker Voice Man comes out every time we break into a server. Just a second, everybody.
Hey everybody, it's me, Scary Hacker Voice Man.
Planet! Hack the planet! Shut up again!
Scary Hacker Voice Man comes out every time we break into a server, and we just broke into this one. Well, Mr. Veneno Administrator, it seems like you like PHP pages that are vulnerable to local file inclusion. Well, that is a big mistake. We managed to find out what the parameter name is for the local file inclusion, and then we use that to leverage some PHP
Mr.
filter
Hackney, please be
chains.
excused from class.
Well, Carl,
Yes.
you hear me? You got it.
Hack.
You got it.
Hack.
You did.
Have a great day.
I hope you knew about these problems and that you go to hack and have a great day. But anyways, now we're in.
Okay, we broke in. We need to figure out which... I mean, there's Python on this thing, right? Yeah, Python 3. Python 3. Let's stabilize our shell. pty.spawn bin bash. What was that? Well, that was Mr. Scary Hacker Voice Man. He comes out every time we break into a server. So we just broke into the server here, and what we need to do is... Oh, did we break our shell? It looks like our shell is broken. Our shell is broken. Oh, that's no good. Alright. Let's run the command again. Actually, is it still... No. Okay, we need to run this command again. Stop. Re-go. Do the thing again. Okay. Let's get the command again. PHP. Come on, let's go. Whoops. Here. Okay, and then we should be able to get in again using netcat. No? Did it not work? We might have to switch up our... Get a stable shell, on Python 3. I mean, the last time we got a stable shell using Python 3, the shell broke. So I don't know about that. Okay, netcat doesn't seem to be working. Yeah, it's not working. Get a shell and then move over to the Venom. Okay, so this thing didn't work. I think we might have to change our... We might have to change the port number. From the previous shell? Could be. Yeah, let's change the port number. So instead of 443, let's go with some arbitrary port number. How about port 1337. 1337, it's going. Delete port. Okay, we're in again. Okay, what is this Antiguo y Fuerte? Antiguo y Fuerte. Fuerte means hot. I don't know about Antiguo. Okay, so... what does this say? I guess we can figure it out with some... Translate. Google Translate. The socket was already made. It's impossible for me to remember the password. It's unhackable, but I know I've had it in the same file for 24 years. Try looking for it. I'm the only user on the system. So, I mean, we're talking about Carlos, right? That is Spanish, yeah. So, 24 years. So, what was 24 years ago? So, we're looking for, it's like a find command. Find command, file older than 24 years. To find files older than 24 years using the find command in a Unix-like operating system, you need to convert 24 years into days. So, okay. We can give it a go. Move into the temp directory. Can we move into the temp directory? What directory are we in? We're in the HTML directory. We can't move out of the temp directory. What's going on? Does that mean that password is back in the etc password file before they moved it into etc shadow? Hold on, I think we can't move into other directories. There's something wrong with their shell. Bash. This is weird. This is strange. You know what? It's fine. Let me craft my payload first. So search the entire thing, look for files, output to devnull, run this thing as a background process. Okay, probably bind. The bind shell is not persistent storage. A persistent session depends on the bind shell and the OS you're attacking. Okay, so we've got an unhackable pass.txt file. So we can read it. Okay, I think we can log in as the Carlos user now. so we'll call this SSH. Carlos at okay, we're in. We're Carlos, no, don't start the password as a TXT. What are you doing, Carlos? Panaco Panko, hey, welcome to the stream. Why are you up so late? Let's give a shout out to Panaco Panko. Panaco Panko is another Twitch streamer who does some cybersecurity content. I was expecting a hash to crack, not plain text. Nice. Okay, so I mean, we've got an actual shell now. So we just need to sudo. There's no sudo. Let's move into Carlos's home directory. Based password storage. What the? Why is there all this crap in here? What is a carpeta? Alright. Google Translate, don't fail me now. File. Okay, a carpeta is a file. It's a folder. So, I mean, this really reminds me of... What is in these directories? There's nothing in these directories. Maybe Carlos was a rug salesman. Yeah. Maybe not. You're not a real sysadmin if you don't store it as TXT. Okay. This is what we're going to do. So we're just going to find in the current directory, type file, and that's all we need to do. Okay. So we've got a tor.jpg. All right, let's go ahead and take a look at that file. Tor.jpg. Funny. Okay, so strings. There's no strings. File. Well, I mean, this is going to be a JPEG file, right? There's no file command. How about we just read the thing and then move it over to our other machine? Wait, did I not shut up Panaco Panko? Oh, I did, okay. Please mention the Twitch link to the other cybersecurity streamer who joined the chat. Yeah, let me pull up the link, because it should be on InfoSec streams. I forgot the dot. Laughensec is online right now, wow. But yeah, Panaco Panko's link is over here. I forgot the dot. Where is it? Oh, this dot. Okay, so we just need to turn this into base64 content. After that, we can copy this and then we can turn it back into the original file on the other end. Wow, this is big. Why is it this big? Whoa. Alright. Well, just keep on. This is going to take a while. Just a second, everybody. Really big file. Really big file. SCP says, am I a joke to you? You know what? If I knew how big this file was, I would have used SCP. But that's okay. It should take another 10 seconds or so. Holy moly. Holy moly. Just a second. So this is an example of what not to do. You don't do it like this. Okay, so this is my base64 content. I'm going to copy this to the clipboard. Then I'm going to go to another terminal, like this one. And then I'm going to create a file called jpeg.b64. Paste in all this stuff. Save it. Read the thing. 10 seconds, yeah, it wasn't exactly 10 seconds. Let's see. So cat jpeg.b64, pipe it into base64 decode, and output it as I don't know, carlos.jpg, like this. Okay, and then open up carlos.jpg. What is this? It's a penguin. It's not dumb if it works. It's not dumb if it works.
Hack the planet! Hack the planet!
Okay, I mean this doesn't exactly help us. It is a pretty cool image. So let's see. Let's run exif tool, because that's what we do with these things. Okay, so there's nothing super... What? Whoa, what? Is this a password? Is this the root password? That was the root password! Hey everybody, we didn't need to do steganography. We found it in the exif data. All right, you know what? That means we can do this.
What are you?
I'm system root.
Frackery asks, what image quality password okay. Image quality password okay. What was the command again? You're talking about, it was just exif tool. So exif tool gives you, information about the thing. Image quality was the root password. Yeah, exactly. The gifts bring me so much joy. Yeah, for sure. Thank you. And Panko, I think I should be able to implement your emote over the weekend. Panko graciously used her precious time to create an emote for the channel, and we're gonna be implementing it in over the weekend. Okay, let's move into the root directory, and this is .sh. We're just going to create a little graffiti file in here. Graffiti.txt, and hello admin. This is the HackerFrogs, and we just hacked you. Your PHP pages were vulnerable to local file inclusion. Lamau. Kitty face. Well, actually, that looks pretty good. Yeah, and let's see. We used LFI to run filter chains and get RCE. You decided it would be alright to hide your password in old files and hidden images. That was fun to find. Better luck next time. And thanks for the access. Okay, so we left our calling card, and now we're ready to finish the box. Let's see. Gunpowder says, I keep my plaintext password and image file too. It's, yeah, it's so much easier to do. Let's see. Junior Sesh says, I'm a beginner. What should I know before starting CTFs? So let me, Junior Sesh, let's, why don't you join the Discord server? Join the Discord server, come and say hello. Write it into a file with the command. Arise Heart, hello, nice to see you here. And, yeah, we're just going to be, I keep my password in the RockU database. That seems like a good way to do it. Okay, everybody, before we go, let's talk about what we're doing next week. Laughensec, we might be able to raid into Laughensec today. But let's see what he's doing. But what else? Let's talk about what we're doing next week. So we do our stream schedule on the HackerFrogs subreddit. And we've got our week 36 schedule up already. Okay, we're going to be doing more games. We're going to be playing, we're going to be doing more Linux hacking. We're going to be doing more web hacking. And we're going to be doing more low-level stuff. So, let's see. You don't put your passwords on GitHub in a public project or a public S3 bucket for all to see? I mean, that's the strategy, isn't it? Okay, Laughensec is here. Awesome. All right, everybody. We're going to be raiding into Laughensec. When you arrive on Laughensec's channel, if you could give this message right here, OSFrog, hip, hop, hack, OSFrog, I would really appreciate it. Okay, let's get the raid started. Laughensec is doing hacker office hours, and looks like they're doing some web enumeration. Okay, so everybody, thank you very much for coming by today. We did a lot of hacking, and hope you learned something. All right, everybody, we're going to be raiding out. Have a great weekend, and we'll see you on Monday. Ready to raid in 5, 4, 3, 2. Oh, you need the Discord server. Discord, here it is. There's the Discord server link. Ready to raid in 5, 4, 3, 2, 1. Have a great weekend, everybody.